Okay, we'll make a start. The next 8 minutes or so, I'm sure more people will arrive. The important thing is we start the first talk on time. So welcome to SEGHLive 2. So yeah, it's good to have a second meeting. We had the first SEGHLive online meeting last June as a quick replacement for the postponed Kenya conference at the University of Eldoret, which was postponed to this July, and we've postponed it again until October. Obviously, these are unusual times, and this seems to be a very good format for meeting together. Last time we had about just over 100 people registering for the event from 35 countries, about just under 30 talks, and it went very well actually. And I think we had a number of people that we hadn't seen before engaging with SEGH from perhaps countries in Francophone countries. Often we haven't seen from Africa, but also I think it was quite an equitable way for people to access the conference in that there wasn't a cost in travel. So we decided to run another meeting, and we're pleasantly surprised by the demand. After the positive feedback in July last year, we're surprised by the uptake for talks, and we have quite an interesting program, I hope, for you. What we have done this time is we have focused on Europe and Africa and East thereof. So the Americas will have their own separate meeting later this year. So that helps us to overcome the time zones a little bit more easily. These talks are being recorded, I think. Is that right, Olivier? Yeah, good. So the talks from last June were recorded and are on the website behind the members area. So you need to log on to the website behind the members area. And if you've forgotten how to do that, you can request your login details again. And also remember, that's how, if you've got the membership with the journal, that's how you can access the journal. We also have a number of resources behind the membership area for early career researchers. So there was a training event in November, which Ariadne we'll tell you about at the end of the conference session. So we have a number of growing activities to serve this sort of multidisciplinary society that is spread across the world in the 50th anniversary year of SEGH. So we have, hopefully we'll have a conference this year, a physical conference, and we may well supplement more of these online conferences if there is the demand to provide the presentations and to listen to them. We will continue a number of early career researcher events for training and networking. We have a series of special review papers and commentary articles that our first speaker, Maurizio Barbieri, is coordinating for the handling of the papers. So those will be released through the 50th anniversary year. And I'm sure I've forgotten a few other things, which I'll try and remember for the end of the meeting. But we're trying to increase the interactivity with the membership, and we do encourage members to please get involved. And if you want to offer any material for training events or articles for the website, or get involved in any other way in networking, please do get in touch with us. And you can do that either directly with one of us on the board, and you have representatives in each region, or simply just log an inquiry through the website. Okay, so we've got a few minutes until Maurizio starts. Just many thanks to Olivier for putting all of the slides together and for doing all the technical stuff in the background. Olivier was the person who made it run very smoothly in July. And many thanks to Anthea for helping to coordinate memberships and registrations in the background. And also to two new participants in the running of the meeting. We have Maureen Ondeo, who you will, from the University of Eldoret, and her colleague Melvin Otieno. So they will help coordinate some of the questions during the day. And I'm sure that they have been involved in organising some of the Africa region's network meetings. So we'll try and keep to time. I do ask you, if you can keep to time. We will give you a warning just in advance, 2-minute warning. This is a very tight schedule, and it works by flowing quickly and staying on time. If you do go over, I'm afraid what we will do is just mute you. Okay. If you've ignored the warning, we'll mute you. If there is a technical difficulty, don't worry, we will try and allow for that. That isn't your fault. It may be if we lose you whilst you're speaking, we will try and come back to you later. We'll just go straight to the next speaker, okay, to try and keep the flow going. So what we will do is we have a few longer presentations. So we've got a couple of keynotes that are 12 minutes long, and we'll have 3 minutes for questions straight after those. So that's Maurizio Barbieri in the first session, and then Akira Takeda at the beginning of the second session. And then for the rest of the talks, we will group them into a batch of 4, and we will roll the talk straight one into the next, and then we will have the questions at the end of those batch of 4. And then we'll have all of the speakers on the screen, and you can present your questions to those 4 people. Okay, so that seemed to flow very well in the last meeting. And then we have a couple of examples for early career researcher keynotes, which we're testing today on a couple of people, which are slightly longer than the 5 minutes. They're 8 minutes, just allows a little bit more in-depth speaking for early career researchers. So if you like that kind of format, then we would encourage others to try that if we have another meeting. Okay. So I think we're up to just over 50 people online. So I think that's all of the business in advance, Olivier, isn't it? Do you want to say hello, Olivier, so they know who you are?
Good morning, everybody, or good afternoon, or maybe even good evening, depending on where you are. Yeah, welcome to SEGHLive 2. I think we've got a really exciting schedule lined up for today. So if Maurizio, you could start sharing your screen, and
okay,
I'll just stop sharing mine.
Okay, you can see my screen?
Yes.
Okay.
If you could just make it full screen, that would be great.
Yeah. Okay.
And, if we could, that's good.
Okay, good morning to all. This is my presentation about legacy of arsenic contamination in an area coming from southern Italy, and this is a very interesting for us case study, and we are studying this area by 20 years. And this is an historical case study of arsenic, ammonium, nitrate and phosphate pollution in a coastal aquifer beneath a former fertilizer production plant in southern Italy. This aquifer has been subjected to an active groundwater remediation based on a large-scale pump and treat scheme activated between 22 years. And this is the investigation area. This is the south of Italy, in particular Sicily, and this is the plant, the fertilizer plant, and you can see that this is the area, and these in red are the 17 pumping wells for the large-scale pump and treat scheme. And the pump and treat scheme now prevents the migration of dissolved contamination plume into the marine environment. However, given that this is located in the proximity of the coastal line, a seawater wedge has been induced by the pumping wells in this area in particular. And despite of the long-lasting elevated groundwater concentration of arsenic, just is in coming about 100 ppm and are still locally present in groundwater with highest concentration found in the most permeable layers. The aims of our study a long time was to reconstruction of arsenic distribution in groundwater, determination of arsenic content in sediment. Do you remember that arsenic was only one of the other pollution compounds? And we stress about the arsenic behavior, but we made some arsenic sequential extraction and the lab experiment in batch column test, and with the aim of make a geochemical and groundwater transport model all of this study was with the aim of designing a field test for the decrease of arsenic concentration in groundwater through an active remediation strategy. From hydrogeological point of view, the aquifer thickness range between 20 and 30 meters at the study area, and it is mostly consists of sand and interbedded by clay and silt. Arsenic pollution is limited to the western section of the area, where they're going with the okay, this is the source zone, and this is the plume. You can see the very high concentration between 2011 and 2016. And by historical groundwater characterization, you can see that arsenic, highest concentration found in the most permeable layers and in suboxic zone. This is historical graphics. And you can see that we have a plume coming from ammonium, nitrate, phosphate, and arsenic. And the general decrease of pollution concentration, but the arsenic is still present at high concentration, still of 100 ppm. So we make last 2 years, in 2011-8, three couple of monitoring wells, one located in the arsenic source, this one, and 2 other ones located the gradient of the arsenic source. And okay, you can see coming the results coming from digestion results obtained. You can see that arsenic in core sediments have a high concentration, still 20 milligram per liter in groundwater in the blue, and this is the concentration in ppm of arsenic in core sediments. And arsenic highest concentration have been found in the most permeable layers in suboxic zone. This is clear from the background and the reference coming from the literature. This is but the results coming from sequential extraction obtained highlights that arsenic is associated with amorphous iron oxide in all of the sediments core. Okay, we make so the lab test with the aim to decrease the arsenic concentration. So we treat the batch sediments with some compounds like sodium nitrate and iron sulfate. And we use 2 different water, one brackish water and once in another batch, the site groundwater. Going to the most important results, I think that you can see this one is better. The treatment batch, when we used the site groundwater with the same solution of sodium nitrate and iron sulfate, we can see an strong decrease in arsenic concentration coming from 5 days from the start of the lab test. So this is very interesting results for us, because we have even a control batch with the site groundwater with core sediments without compounds, chemical compounds. So you can see the very important difference in concentration of arsenic that remain in the high level without treatment. So these results was just published, and the long-term pump and treat remediation system has modified the natural groundwater flow condition, but failed to diminish concentration in groundwater. The pump and treat is necessary for decrease all the contaminant, but have an effect on the contrary for arsenic concentration in this area. So we decide to. There is a problem. Okay. For this reason, a comprehensive characterization campaign was formed. Digestion process results reveal that highest arsenic concentration are related in most permeable layers. Sequential extraction highlights an elevated presence of arsenic associated with amorphous iron oxide, and the batch experiments results show enhanced arsenic decrease when we treat these sediments with sodium nitrate and iron sulfate. So starting from these results, now we are approaching another type of test site and modeling, coming from this interesting paper just published in Environmental Geochemistry and Health last year, and that is like our case study, because this is an impact process of aquitard to regional arsenic accumulation of the underlying aquifer in central Yangtze River Basin. But the most important difference that is that in this case is without extensive groundwater pumping. So the results of this study is like us study, because you can see that you have an high arsenic concentration when you have a downward flow. This is normal, but in our case, the pump and treat system can change in a very important situation, like actually is the arsenic concentration in the aquifer. So starting from the previous results and coming from this interesting approach that we have just read from coming from this paper, the next study's major purpose is to reveal the aquitard process to the regional arsenic accumulation on the underground aquifer under a different pumping level. So the new aim of our study is to understand if we have a different pumping levels, what happens in the arsenic concentration, what would be happened in the aquifer concentration about the arsenic concentration. This is very interesting, but actually we can't stop the pump and treat because we have other chemical pollution compounds. So it's necessary to understand the better level of the pump and treat for the arsenic concentration. That is the aim of our study. So this is our teams that are working on this study, and you can see that we are a team coming from all over the world. We have colleagues coming from Australia, from China, and from USA. So I hope that I'm time and I'm open to the discussion, or I will wait for the second presentation and then the discussion. I hope that was in time, okay?
Yes, perfect. You were 2 minutes ahead.
Okay.
Maybe we have time for some more questions. It does allow me to introduce Maureen Ondayo, who will be fielding questions, hopefully. Maureen, do you have questions for Maurizio? And many thanks for your talk and for opening the event, Maurizio.
Okay.
Maureen. You're on mute, Maureen.
Thank you, Maurizio, for that great presentation. In case you have a question for Maurizio,
yes,
kindly raise your hand and direct it to the presenter. And if you...
There you go.
Okay, we have one question for you, Maurizio, from Alex. Alex is asking, thank you, where does the arsenic go?
Okay, the arsenic coming from the sediments, but the real problem was the water rock interaction with an existent flow coming from the pump and treat. So the arsenic that actually is in mobile position, okay, because is related to the very low absorption by the oxide, the iron oxide clay sediments with high organic matter. And so the arsenic is very mobile, coming under redox and high redox condition that are starting from the flow by the groundwater. So in our case, we can we would to entrap arsenic in a very immobile position with these typical compounds like sodium nitrate and iron sulfate. And in this case, we tried that even under redox condition, this type of arsenic was not under mobile condition. But the real problem was to understand for the future which how many arsenic will be under mobile condition without or with a low or a different groundwater flow.
Okay, thank you.
Yeah, I can share our first
Back to you,
results,
Michael. Thank
just published to all.
Okay. Maurizio, if nobody else has a question, perhaps can I ask, are you connecting this through to the drinking water? I may have missed that in your talk.
Okay,
thank you.
No, this is not for drinking use, this type of water.
Is there a connection between the aquifer? So
Yes.
it isn't being used at all?
No, unfortunately.
Okay.
At this moment.
Can I ask questions?
Yes.
Go ahead.
Thank you for your presentation. About this area, Campican area, there is, I think, 4 papers from Stefano Albenso from Naples University and Benedetta De Vivo, which studied this area, that conclusion that in the paper in the Journal of Geochemical Exploration, that noted that the arsenic in this area is related to sediments, surface sediments, and some geogenical sources from limestone in upstream lithology. About your observation wells, I think that 3 observation well for this study is is low for your conclusion. How did you conclude that arsenic can be observed in the piezometric or observation wells?
Okay, in our case, the arsenic coming from the is coming from anthropogenic input. Okay, not coming from geogenic solution, and because it's clear that in this case we have an old industrial plant that is the main source of arsenic. Okay, and the real problem is that in this case, with this groundwater flow coming from the pump and treat system, you have a very high release of arsenic, and it's normally, but it is necessary to have the pump and treat because we must decrease the other chemical compounds. But in the case of arsenic, we are now studying which will be the better or the more degree of hazard in this case about the which will be the level of the pumping that will be normally for the arsenic concentration, but or in the other case we can entrap arsenic with chemical compounds. We have a test site about this, and our results are in good correlation, and we have a very low mobile of arsenic when we treat the core with this type of chemical compounds like sodium nitrate and iron sulfate.
Thank you.
Okay, great, thank you. We're going to have to move on to the next talk. Can I ask that you post your questions in the chat box, please, and then Maureen will line them up because we're going to go from one talk into the next. So if we could, many thanks for opening the event, Maurizio.
Okay, thanks a lot.
Thank you. So we're going to move on to the first of the run of 4 talks. So Lydia Alaka from the University of Nairobi.
Okay, Good morning, everyone. Good afternoon. So my name is Lydia Olaka, and based at the Nairobi University, and I'm going to talk about fluoride enrichment in the groundwater in Central Kenya Rift. This is work that we've been doing for a while now. Okay, so next. So why fluoride? Basically, fluoride is an essential micro element which is required in a very narrow range between 0.5 to 1.5 ppm for normal growth in body organs, especially bone and teeth. But when the levels are high, then it causes fluorosis. And this has been reported in various locations in Africa and also in Asia. And a bit of South America. If you can look at the map, which is presented on the right-hand side, you can see the dark areas are a map from Amini et al. In 2008, where they mapped out these areas. So fluoride is an abundant element in the crust, and so it is found in various rocks, but its concentration in groundwater is dependent on a number of factors, looking at temperature, the geologic formations, and also the residence time. So a number of studies have been done in East Africa, and they have found fluoride to be quite high. And also with that, dental and skeletal fluorosis has been reported. Next. So this is the study area which we are interested in. Two things to pick from here is that basically we have a lot of volcanics in the area. It's also an area with active rifting. And around the lakes, we have some lacustrine sediments, which are reworked volcanics. And on the right-hand side, what you're seeing there is the sample areas sample sites that we collected samples from. So we collected rocks, groundwater, and also surface water. And to note is basically that within the rift floor that is a bit yellowish there, this is an area which is quite arid. Next. So these are the, basically the surface and groundwater demand in the rift presents itself like this. We have groundwater, surface water, both for animals and also for humans. And of course, fluoride affects both animals and humans. And what is also interesting here within the study area is that you have some of the areas with this steam. So in the next row, the second row, you see this structure there, where residents actually harvest steam and cool it and drink it directly. And then on the right-hand side, we also have, you can see that in the middle right-hand side, you can see that we have the geothermal wells, which are drilled up to about 3 kilometers deep. And these also have high quantities of fluoride. Next.
Okay, 2 minutes.
So, yes, my objectives basically are just to map out what are the sources of fluoride in groundwater and surface water, and what are the mechanics of enrichment. Next. So what did we find out? We found out that actually from the 76 samples that we collected in the area, 73% of water is actually above the health guideline of 1.5 milligrams per liter. You see that we had both, we collected samples from the wet season and the dry season. There's a little bit of a dilution in the wet season, however, the levels are still high. And there's more fluoride in the surface water compared to the groundwater. Next. So to look at the relationship between fluoride and chloride, this basically helps us. If we look at the map here, you see the orange areas are the areas where we have high chloride. And also those are the areas where we have this higher fluoride, some of them and not all. This basically helped us to map out and see that we find fluoride on the reef floor in the areas where we have the lacustrine sediments. And also these are the areas that has high fluoride. So it seems like there's a relationship between the two of them because of the enrichment due to evaporation. Next. The REX samples also showed very high fluoride. Next. So here is basically what we see, that we found, we were able to map them into 3 clusters. Those that are enriched by evaporation, those that are enriched by geogenic processes, and then there's mixing between the two next. So in conclusion, we can say that fluoride is enriched by the three processes: evaporation, mixing, and also rock alteration, dissolution. And then we also find that within the reef floor, there's quite high fluoride, and then there's also dilution effect. Thank you.
Wonderful. Thank you. You finished just on time for your phone call there. That was good timing.
No, it's my alarm.
Okay. Great. Thank you.
It's the timer.
Wonderful. We'll move straight to the next talk. If you can hang around, and we'll have all four of you on screen for the questions later. So people do please post your questions. So we're going to move to Konstantina Pregaki. I do apologize for any of my pronouncements. Do correct me if...
Good morning. My name is Konstantina Pregaki, and I'm a PhD candidate at the National Kapodistria University of Athens. I'm going to present a part of my PhD thesis regarding human health risk assessment of chromium in drinking water of the Filtraki Basin. Next, please. It is known that hexavalent chromium is a known carcinogen when inhaled, but its carcinogenic potential when orally ingested remains controversial. According to the European Directive for Drinking Water and the WHO recommended value, the upper regulatory limit is 50 micrograms per liter for total chromium, while for hexavalent there is no upper limit legislated. There is evidence that ingestion of hexavalent chromium compared to trivalent drinking water results in increased chromium absorption. So not all the hexavalent chromium is reduced to trivalent chromium in the cell. Therefore, the precautionary principle and the growing body of scientific evidence mandate that as a scientist we regard hexavalent chromium as a human carcinogen by ingestion. Next, please. In the alluvial aquifer of Filtraki Basin, hexavalent chromium occurs in groundwater is zeogenic due to the interaction of water with the serpentinized ultramafic rocks. You can see the geological map where the green is the ultramafic rocks. A total of 28 groundwater samples were collected from 11 sampling stations during the wet and dry seasons of 2017 and 2018. And hexavalent chromium concentrations were determined according to the different Paradise method, which is a spectrophotometric method with a limit of detection of 0.09 micrograms per liter. Next, please. The groundwater hydrochemical type in the Filtraki Basin in the alluvial aquifer is of magnesium bicarbonate, as you can see in the pipeline diagram. And on the figure 3, on the left, you can see the land use map and the 11 sampling station. You can see that the largest percentage of the basin is forest land, and the red is the urban fabric. Next, please. Hexavalent chromium concentration as well as total chromium concentrations are stable among the 4 sampling periods, as you can see in the box plots. On the left is for the hexavalent chromium, and on the right is for total chromium. You can see that in some cases the limit for total chromium is the concentration exceeds the upper limit, which is 50 micrograms per liter. Next, please. So for the health risk assessment, the deterministic approach of the United States Environmental Protection Agency formula was used. According to this method, 2 major indices, the hazard quotient as well as the chronic daily intake were calculated according to the following equations, as you can see. The values of the different parameters are also shown. And the potential carcinogenetic risk for injection were calculated according to by multiplying the chronic daily intake with the corresponding cancer slope factor, which in case of chromium is 0.5 milligram per kilo per day.
Okay, that's just under 2 minutes, please.
Yes, next.
Okay.
Here are the results of the health risk assessment. You can see on the left the non-carcinogenic risk for the adult group is low, while for the children group is medium. And on the right, you can see the cancer risk. For the adult group is high, while for the children group is very high, according to the scales of USEPA. So next slide. So to conclude with, hexavalent chromium concentrations in the alluvial aquifer of Lusrachi range from approximately 20 to 62 micrograms per liter, exceeding the upper limit for total chromium for drinking water. The non-carcinogenic risk for adult and children groups was found to be low and medium respectively. The carcinogenic risk for adult and children groups was found to be high and very high respectively. And there is a need to further examine the potential health risk by implementing more in-depth analysis through probabilistic risk assessment and epidemiological studies. So, next slide. Next. Thank you for your attention.
Wonderful, thank you. And you're on time, thank you. If you can stay around and we'll pull you back for questions with the other people in your group. Okay, yes. Thank you. And please do post your questions. We have a couple already for Maureen to ask later. So we'll move on to the next speaker, Elliot Hamilton, please.
Can you see that?
Yep.
Okay.
You go.
So yeah, so my name's Elliot Hamilton. I'm an environmental chemist working in the inorganic geochemistry labs at BGS, and thanks to Michael and Olivier for the invitation to present today. So I'm going to give a more generalized overview of the current trends and future perspectives of elemental speciation in the context of chromium. So when discussing elemental speciation, it is important to understand what is meant by the term, as a couple of definitions do exist depending on the research area. So the International Union for Pure and Applied Chemistry, or IUPAC, defines elemental speciation as the distribution of an element amongst defined chemical species in a system. So within this, chemical species can be defined as the specific form of an element with respect to isotopic composition, oxidation state, or molecular structure. So for example, arsenic or chromium have two inorganic species with differing chemical properties due to their respective oxidation states. So to effectively measure the concentrations and distribution of these chemical species, some form of analytical activity is required that is capable of both separating and identifying one or more of the individual species within the sample. And this comes with its own set of considerations depending on the strategy. So this presentation discusses current elemental speciation strategies and future perspectives in the context of chromium, which was an element whose speciation in soil and aqueous solutions I did investigate during my part-time PhD. But the considerations that would be detailed can also apply to the speciation analysis of other common species such as arsenic and selenium. So the rationale for chromium speciation, just to build on what sort of Konstantina said earlier, was is it's present in the environment as two inorganic forms. So the trivalent form is an essential micronutrient for glucose and lipid metabolism, which has led to its widespread use as a putative weight loss supplement, whereas chromium-6 is toxic and a recognized carcinogen through inhalation. The majority of chromium-6 is released into the environment anthropogenically through industrial processes such as chrome plating or leather tanning, but as you just saw, there can be geogenic sources of chromium-6. And due to its species being negatively charged, chromium-6 is more bioavailable and more mobile in soil water systems, and is therefore more likely to be transferred into plants. So the current trends for chromium speciation analysis do mirror those of other commonly studied species, and they do primarily concern the preservation of sample integrity, which can be compromised throughout the sampling, storage, and analysis process. So my PhD research did focus on the development of techniques to measure chromium species in solid sample matrices, but the trends highlighted do cross over to aqueous solutions. So speciation analysis can be broken down broadly into two categories, offline and online. So offline speciation involves the separation of chemical species, for example, through selective extraction prior to determination using a suitable analytical technique. So offline methods require minimal sample preparation and are relatively inexpensive to undertake, but they do rely on the underlying assumption that all of the chromium measured in the extract is present as one specific species with no interconversions taking place during the procedure. So this uncertainty has led to a number of online methods being developed that combine separation and detection. The most common of which is the coupling of a chromatographic separation technique with a sensitive detector such as ICP-MS. And depending on the capabilities of the lab, online techniques can either be considered a routine commercially viable system or impeded by the requirement for expensive instrumentation. Currently, the gold standard of online solid speciation is to employ speciated isotope dilution mass spectrometry, so using species-specific isotopic spikes to account for interconversions. So one aspect of my PhD did require the optimization of an SID-MS strategy to measure hexavalent chromium in soils contaminated by mining activity in the Copperbelt province of Zambia, but this technique has also been used by other groups to measure hexavalent chromium in food samples amongst other solid samples. So very briefly, SID-MS does operate under the same principles as conventional isotope dilution, except that the spikes added to the sample are in the same speciated form as that under investigation. So once introduced, the sample and spike are equilibrated before online separation and detection to measure the isotope ratios between native and added species. So this allows for both the concentration of the species to be determined, and if two isotopically unique species are used, then the degree of interconversion between the two species can be calculated. So to come back to sort of current trends, one of the largest hindrances in speciation analysis is actually confirming the accuracy of data produced from a particular strategy. So the most desirable way to establish quality control measures for speciation is to measure the species of interest in a certified reference material which matches the sample matrix that you are studying. So for example, for the SID-MS speciation strategy that I employed for my work, I processed CRMs for contaminated soil in the same way as the samples to ensure the accuracy for the soil data for unknown samples. And typically the drivers for CRM production are usually dependent on demand from regulatory agencies, including occupational exposure assessments and evaluation of food supplement safety in the case of the welding dust and the yeast seen there.
Elliot, that's a minute and a half. Okay.
So I'd now like to switch to consideration of future for speciation for the last couple of minutes, just addressing some promising new developments in the last few years. So although not new by any standard, the use of solid phase extraction or SPE cartridges to undertake field-based species separation is a surprisingly underdeveloped area of research. So depending on the media used, a variety of species may be separated and preserved at the point of sampling, which will further reduce the risk of species interconversions. There's also an emerging field of cheap, rapid speciation using field instrumentation powered by smartphones, although further development is required to address currently high detection limits. For online techniques, and particularly chromatography, there are a number of potential advances based on the modification of the stationary phase, which therefore require minimal sample pre-treatment and drastically reduced analysis times. And finally, recent work undertaken by our group suggests that coupling passive sampling techniques such as microdialysis can allow for near real-time study of chromium species in soil solution to understand redox dynamics changes. I'd just like to thank the following people for all my progress over the PhD, and I'll wait for any questions at the end. Thank you.
Great, thanks very much, Elliot. Running to time, and if you hang around like the others for the questions, and we'll just have the final one in this short session. Suleiman Usman, please. Do we have Suleiman? You're on mute at the moment. There you go. Away you
Okay,
go.
are you hearing me?
Yes, we can hear you loud and clear.
Yeah, thank you very much. Good morning and afternoon, everyone.
Good morning.
My name is Suleiman Usman from Department of Soil Science, Federal University, Jigawa State. And I want to talk on environmental pesticide and its toxicity, which we consider, based on the work we are doing, as a global concern. Next, please. What we need to know is pesticide is a substance which normally produce. Hello? Hello?
We can hear you very clearly. Carry on.
Okay. We are on introduction. The word pesticide came from two terms, namely pest and side. As we know from a general term, pest is a name used to define any plant or animal or soil organism which is detrimental or harmful to soil and biological organism, while the term pesticide is a Latin word that means to kill or to destroy a pest. Next, please. Next, please. From the image you are seeing is a combination of a broad series of pesticide normally used here in West Africa. Pesticide ingredient. Pesticide are specific chemical which contain both active and inactive ingredients. Active ingredients are sparkling and capable of preventing or destroying or repelling or mitigating a pest of plant and human vectors. While inactive ingredients are stationary, in another term, they are immobile. They stay in soil. Next, please. Generally, our concern, based on the work we are doing in our department, is specifically on pesticide toxicity. Why? Because majority of the rural farmers who are using pesticide, they are unaware of the tremendous effect of using pesticide. If you move around the rural areas where agricultural practices are going on presently, most of the farmers, they use pesticide without considering the importance of hand gloves, the importance of cover clothes, the importance of protecting their body, and this is where the concern is. So based on this, we focus on pesticide toxicity, and this pesticide toxicity can be explained in two terms: acute toxicity and chronic toxicity. Acute toxicity is the ability of chemical pesticide to cause harmful effects in human and biological organisms within a very short period of time. And this is highly related to most of the cases that is happening with regard to rural farmers. And the chronic toxicity, on the other hand, is the ability of chemical pesticide to cause adverse health effect, which follows from long-term exposure to a chemical. And this is related to a long-term diseases, long-term problems, which farmers are unaware. Next, please.
Okay, that's about 1.5 minutes left. Okay.
Okay. As we know that these pesticides, they have advantages and they also have disadvantages, but our concern is more on disadvantages of these pesticides. Why? Because as we know that these pesticides, they have both acute toxicity and inacute toxicity. And most of the farmers, they are unaware of this effect of pesticide. So what we are trying is to bring the awareness to the farmers that there is need for them to understand what toxicity is all about and what are the disadvantages of this pesticide, because they are only aware of the advantages of the pesticide. Their target is higher yield of their crop to produce more crop for profit, but their health concern is quite serious. So what we are trying to do is to address the effect of pesticide to them, to make them to become aware of the disadvantages of using the pesticide, and how can they use the pesticide properly for sustainable agricultural development in their areas. Thank you very much.
Right, wonderful. That's just on time. Thank you.
Thank you.
And I can see you're in your car, so that looks very challenging. So thank you for trying. And we heard you very loud and clear. So can we have the 4 people that just delivered talks? And Maureen, do you want to field the questions?
Yes. Thank you, Michael. So we have questions for the past presenters. And the first one was the keynote speaker, Maurizo. Marcelo is asking, what is your position of taking one contaminant at the time instead of looking at how they interact with each other? Then the other question from Wilson is, why was the highest arsenic in permeable layers? Kindly respond.
About the questions about the arsenic and the relationship between the other compounds, we are starting to modeling this relationship. So I hope that in the next 2 months, we have some results coming from this type of approach. It's very difficult because we have a source in this area that I proposed to us. In this area, we have 3 different compounds, chemical compounds: nitrate, phosphate, ammonium, and arsenic, that are very different. And we have a very important problem related to the seawater intrusion, because only by 1 year we have stopped this type of water rock interaction in the studied area. And so only at this time we are now running to proceed to understand the real relationship between the 3 different pollution compounds without the interaction coming from seawater, because still 3 years ago we have a river that running around the seawater, and that was very there was an interaction between seawater and the groundwater and superficial water. Okay.
Okay, thank you. Thank you so much for responding. We are moving to the next presenter, who was Lydia Olaka. You have one question from Colin Ogore. Would this mean that fluorosis is most prevalent in the central Kenya Rift? Lydia,
Yes. Yes. Yeah, thank you, Collins. Yes, the fluorosis is well, high fluoride water is, and if you look at the rift and the escarpment, you'll find that on the rift floor, there's higher concentration of fluoride. But then there are a few areas where there's a treatment which has been installed, yeah? So people can go and buy drinking water that is passed through bone char. So the level of fluoride is lower compared to other areas. But the people who are drinking directly, we found areas where people were getting water directly with high fluoride, and you could see on the tip that it was high. But since you're a Kenyan, I think if you compare with Baringo, you'll find that there's higher levels as you go a little bit north, because it's drier. Yeah, so it's more arid. Then of course you have the evaporative enrichment of these waters, so they tends to be higher in those areas.
Okay, one more question for you, Lydia, from
Okay.
Ofano. He's asking,
Yeah.
Explanation for more fluoride in surface than groundwater.
Actually, if you look at the explanation for the fluoride in the surface water is actually, again, because, you know, fluoride, its concentration is dependent on a number of things. So the formation itself, the temperature that you have, the bicarbonate concentration. So you find that in the surface waters that we found, especially the smaller lakes, smaller alkaline lakes, there's Colloidian and Sonachi. These ones were very high, and they're high in all the elements, sodium and calcium and potassium, and it's actually, and chloride. So it's related to the evaporation. So the lakes that do not have any outlet, even on the subsurface, and they tend to have very high pH and salinity as well. Here we found very high levels of fluoride. So it's just the evaporation, a temperature thing, though of course some of the rocks that are have minerals with high fluoride, for example, also in those areas there are higher concentrations. This is if you look at, for example, the geothermal wells. Yeah, so you have high temperature, and these then tend to be higher than even the surface water that we found. So there are various factors: dissolution, the geothermal or temperature component, and then the evaporation.
Okay, the next presenter is the next presenter is Constantina. You have two questions. Do you know if there are carcinogenic incidences in the study area? Number two, from Cape Torrance, what is the source of chromium in the aquifer? Is it natural?
According to the literature, there are no epidemiological studies in the Lake Basin, so this is something that have to be investigated in the future. So no, I don't have such information regarding if hexavalent chromium in drinking water is related with cancers in children or adult groups. And for the second question, yes, hexavalent chromium is a geogenic in the alluvial aquifer of Loutraki due to the fact that the material of the saturated zone and unsaturated zone, it consists of weathered material which is derived from the erosion and weathering of the ultramafic rocks. And so we have minerals such as serpentine, minerals, pyroxenes, and chromite, magnetite, which can be active sources of chromium. And this also have been published recently. So yes.
Okay. So I also have a question for Suleiman. The next presenter. Yeah, Suleiman, you thank you for your presentation.
Okay.
I was asking, did you identify specific pesticides or various pesticides and advice according to their toxicity and benefit levels? Because what I understand is that some pesticides are beneficial, and we have the safe levels. So did you identify particular ones, or are you just talking about general pesticides?
No, we are not talking about the general pesticide. We are specific on the pesticide used by farmers in the region, and the study is ongoing at the moment. We set a first step to identify the specific pesticides used by the farmers in the area. But due to the COVID-19 and the lockdown, we stopped that. And hopefully, probably this month, between this month and next month, we will carry the research again And after identify the specific pesticide within the study region, then we will go to the market area, buy the pesticide, and then take them to the lab for analysis, because we are targeting on the acute and the chronic effect of the pesticide at the end of the day, to try to find out the effect of this pesticide, particularly with regard to the skin, the mouth, the eyes, and the body in general, because these are the 4 components of the body that normally acute effect of pesticide occurred. So this is what we are looking for at the end of the day.
Okay. And
okay, great. Thank you, Maureen. I think we need to move on. We're about 5 minutes over. I've just posted a question for Elliot. Perhaps he can answer that in the chat room area. All right. We will get quicker as we go through the day. I think we're just finding our feet, aren't we? And we've got time at coffee to make up as well. Can we move on to the next speaker? And thank you for the speakers in the first batch of presentations and for starting off the day. So we'll move to the next speaker, Sophia Dowell, please.
Hi everyone. My name's Sophia. I'm a PhD researcher at the British Geological Survey in Nottingham. My particular research interest is micronutrient and pollution transfer within East African lake catchments. And as part of this, I'm going to be investigating the potential use of fallout radionuclides as soil erosion tracers. Next slide, please. Fertile soil is one of the Earth's greatest resources. However, a large proportion of the world's soils are degraded to some extent. This concern is greater in environments which experience extreme wet-dry weather patterns, as these are what drive both rain and wind erosion. Current rates of soil erosion are not sustainable, and with changes in both precipitation and land cover on the rise, these rates could increase significantly in the future. As a result of this, nutrient shortages in soils are of major concern for the future, and these nutrient shortages could result in lower crop yield and a lower protection against disease. In addition to the effects on land, water quality can be affected by the increased sedimentation that results from soil erosion. This can lead to a loss of storage capacity, and the eroded sediment being transported into the water body can act as a vector for the transportation of harmful elements. A large proportion of this degradation is a direct result of poor land management practices and vegetation clearance, and so there's a need for reliable quantitative data detailing rates of soil erosion so that mitigation strategies can be planned effectively. Next slide, please. Traditional techniques such as erosion plots have been used for many years. However, these methods can lack spatial resolution and not representative at scale. In addition to this, these methods have limitations, including only providing short-term rates and being expensive due to long-term monitoring which is involved. Fallout radionuclides offer an alternative way to quantify soil erosion without the need for expensive long-term monitoring. These tracing methods can be performed within a single sampling campaign and can assess for both erosion and deposition rates. Additionally, by using the fallout radionuclide tracer method, the results are give rates which are representative of all processes which led to that redistribution of the soil. The analysis of fallout radionuclides has proven to be an effective tool for quantifying redistribution of soil for the past 60 years, and these techniques have been used successfully worldwide. More recently, research has been focused on 239 and 240 plutonium as an alternative tracer to the other fallout radionuclides. Plutonium has the advantage of a much greater half-life compared to cesium, and so has the potential to overcome some of the limitations associated with it in the southern hemisphere. Next slide, please. Fallout radionuclide methods are based on the comparison between the activity per unit area of a representative undisturbed reference site and that at a given sampling site. By using the assumption that the loss of radionuclide at a reference site is only due to radioactive decay, soil erosion can be calculated from the loss of radionuclide at that site under investigation. Erosion is indicated by a lower inventory than the reference, while deposition is indicated by higher. The graphs show typical depth distributions for different sites within a landscape for lead-210. The differences between the inventory at a reference site and the sampling site can then be converted into a redistribution rate using a conversion model. An ideal tracer will have spatially uniform fallout throughout the area of interest, and on deposition to the soil, the absorption will be both strong, rapid, and irreversible. Next slide, please.
That's just over a minute, Sophia. Okay.
Yep. The proposed study area for this research is within the Wynnum Gulf area of Lake Victoria, and more specifically the Aroba Valley in Nandi County. This valley has been selected as it's a good exemplar of processes occurring across the Gulf and has been identified previously as an area of increased erosion risk. Within the valley, 3 study areas have been selected with different land management practices and clearance scale for further study to help quantify erodibility across the valley. Next slide, please. Through the completion of this research, the hope is that we can provide an insight into the best fallout radionuclide tracer for future studies, as well as investigate the potential of using plutonium isotopes in the Southern Hemisphere. This will allow for the method to be applied to other areas within the Gulf to better understand the effect erodibility has on micronutrient status. In addition, the data collected as part of the study will be useful for future research into applicability of mitigation strategies to be implemented, defending against future soil erosion. Next slide, please. Thank you.
Okay, wonderful. Thank you. You were ahead of time there. Well done. If you just hang around for questions, and
Yep.
We'll move to the next speaker. Thank you. And this is going to be an unusual one. This is a double header presentation. So we've combined 2 presentations together. So it's slightly longer at 8 minutes. So this is for Job Isabuke and Melvin Otieno.
Yes, thank you for this opportunity. My name is Isabuke Job from University of Eldoret. We are going to co-host this presentation with Melvin Otieno. We are presenting on physical and anthropogenic factors of soil erosion, nutrients leaching, and the depletion in East Wynnum Gulf catchment and their potential health impacts. This presentation is based on an observation study of a big project going on. Next. River Nyando catchment, the catchment of East Wynnum Gulf of Lake Victoria contributes 25% of volume of water into the Kenyan lake, part of the lake, and supports livelihood of about 1 million riparian and agricultural communities. Consequences of land use management system with regards to soil and sediment transfer to the Lake Victoria. Could this have an implication to health by altering nutrition levels of micronutrients and other elements in food? Reaching soil of roots of topsoil, depletion, and nutrient acidity and organic carbon content may happen to the extent that is unknown. Hence, that's why we are carrying this study. Next, please. Next. These are the anthropogenic activities based on the observation. So we are presenting in a form of pictures. From the first corner, this is mixed farming along the steep hills. Then we have tea plantation, paddocking, we have coffee plantation, homestead, and overgrazing around the area. Most of the farmers, farm areas have been altered due to increased population. Next, please. The main issue of soil erosion is steep farming on a steep hill. We have steep slopes around Nandi Hills. We have tea plantation. As you can see, they are farmed in a very steep hill. And also the left corner, you can see a very steep hill where there is a contour farming, which also have an water road. And this an upcoming farm on a steep hill where they are clearing previously there was a forest. Next. Yeah, soil properties are the main problem that cause a rate of erosion. These properties are soil texture, wetness, structure, soil surface. Soil with high sand content is not cohesive and has a high risk of erosion. So from here, you can see different types of soil properties. We have sand, we have rock, we have clay. These are the main problems in soil erosion. Next. Next. Yeah, weather is the main problem because in the Western Winam Gulf, previously, please, in the previous slide. Yeah, in the Winam Gulf, it experiences a lot of heavy rainfall, which is characterized with, I think I'm supposed to be in weather. On a slide of weather. Yeah, it's characterized with heavy rainfall. That's raindrops and can detach and disperse soil particles, washing them to the rivers. And this increases the nutrients reaching into the rivers, hence eutrophication. Please, I will welcome my colleague Melvin Otieno to continue on the sediments transfer. Thank you.
Thank you so much, Job. Concerning sediments, approximately 45% of the land is prone to soil erosion, and notably farming along the riverbanks pose the most risk of sedimentation of the rivers. So this will lead to potential health impacts. And as an observation, the rivers were traced from their sources in the forested areas through farming to the lake, and the erosion in the catchment appears to be closely linked to the land use cover. So there were some activities that went cut across from crop agriculture, livestock husbandry, forestry to small scale industry. Next slide, please. So these are some of the rivers in the basement during dry season, since we visited that site when it was somehow rainy and but partly also dry. So the rivers in the basement, we sampled along tributaries feeding into the main rivers, as you can see in the diagrams. And the possible tributaries helped to observe land degradation. And some rivers were small, and some were wide, and some were even rocky. Next slide, please. Next slide, please. So these are just some of the rivers we sampled, and you can also see that there were, just the previous slide, please. So you find out that in the rivers that were shown there, you find out that the water looked brown, and this shows that the farmland were poorly in a degraded area. So, and there were also rivers that were in a pristine forest and tea plantation. So in this case, in some cases, it was a bit clear, so they weren't degraded. Next slide, please. So this is just two examples of the sediment samples we collected. In the first photo is a mixture of coarse sand with pebbles, and the other one is clay. So sorry, the next slide, please. Next slide. So as an impact, we found that there were extensive soil erosion along the rivers, and some of the rivers had reserved areas whereby you can see in the first picture, it's a sugarcane plantation, and it is next to a riverbank, so therefore there is extensive soil erosion going there, and also there are eroded valley, and also sheet erosion and rill erosion as seen in the photo. Some of the anthropogenic activities along the rivers are as shown above, and there are sugarcane plantation, brick making, subsistence farming like cabbages were grown, and beans. Next slide, please. Also, overgrazing was observed. As you can see, there are animals that are grazing along the rivers, and also some were going to drink water along the rivers. Next slide, please. So this is just a continuation of some of the major activities that are occurring at the river sides: beekeeping, tree nursery, coffee plantation, and also planted forests and seedlings. Next slide, please.
That's about 1 minute left. Okay.
Yeah. Next slide, please. So In conclusion, we find out that sources of the rivers represented forested areas that are quickly being converted into agricultural land, compromising their water storages potentials. This may contribute to the current disaster of uncontrolled increase of the levels of the Lake Victoria. And also the increased nutrient loads into the lake may have resulted into eutrophication and uncontrolled growth of macrophytes that included the hyacinths, the hippogras, and the papyrus that we saw. And this importantly altered the lake's ecosystem.
Soil road cattle tracks contribute to gully erosion, less surface plant cover, e.g. lack of contours farming, which leads to high erosion. The steep farm with crops like maize and beans are highly vulnerable, but steep farms with trees and tea are better protected. Monocropping, for example, tea farming, sugarcane farming depletes the soil nutrients. Sandy soil texture and poorly structured soil are the most affected erosion in the sufficient nutrients due to lack of vegetation. Next slide, please.
Thank you.
Thank you. And we welcome questions.
Okay, thank you, Job and Melvin. We'll come back to you for questions in a moment. So if we move to the next presenter, please. Jacudi Moko. I do apologise for my pronunciation. Do correct me. I think we have a bit of interference. Perhaps you could turn the fan off above you for a moment while you're speaking.
Okay, all right, just a minute.
Oh, okay. No, you seem okay now, actually. Maybe it was someone else. No, the interference is back.
Can you hear me better?
That's better. Okay. Right, off you go.
Can you hear me better?
Yes, we can hear you okay. That's good, thank you.
All right, thank you. Okay, so I'm making a presentation on profiling contamination of wetland sediments in parts of Lagos, southwestern Nigeria. And I'm making the presentation for myself and on behalf of Olatunji ES. Next slide, please. Next slide. Begin. The next slide, please. Okay, so Lagos State is a coastal megacity in southwestern Nigeria. It is commonly referred to as the commercial hub for Nigeria because it attracts a lot of commercial activities here in Lagos State. Geologically, it lies just on the coastal plain of the Benin Formation. And if you look at the map, just beneath there with the blue boundary over it, that's where Lagos is, where this study was situated. It's largely saturated by water with a number of inland streams and swamps, and this informed the choice to use wetland sediments for this study. Next slide, please. Next slide, please. Thank you. All right, so if you look at the two photographs on your screen, the first photograph shows, okay, can we go back to the previous slide? The first photograph on the previous slide, please, shows what Lagos traffic looks like. So you can go back to the previous slide.
So which slide would you like? It's currently on introduction continued with 2 pictures of traffic.
Yeah, the one with traffic.
Yeah, it's on that slide now, I think.
Oh, okay, thank you. Yeah, I can see it. Okay, so the first picture you have there is what Lagos traffic looks like, and the second picture is one of the major markets in Lagos State. This part of the land use pattern of Lagos State, which was where the study was situated. Other land uses involve trading, production factories, talking about large pharmaceutical factories, plastic factories, beverage, and the likes. And also, there's a little bit of agriculture that is that's being observed over there. What all these activities do eventually is is to introduce waste into the environment, and these wastes don't have any sustainable way or mode of management, and so in the long run, it causes challenges. Please, next slide. The objective of the study, next slide. The objective of the study, one is to determine the spatial distribution of potential toxic elements in the area. I don't know if you want the next slide. I can't see it here. And thank you. I can see it.
Okay, that's
and secondly,
please. Okay.
Okay. And then secondly, to ascertain the extent of contamination of the toxic elements and their sources. There you have the map of the study area just there. And for the materials and method, this is just a pictorial overview of how the samples were picked. The samples were picked using PVCs, because we were looking to study trace elements, and so we didn't want introduction from other extra sources. And from the first slide to the end, you see a description below that talks about how these samples were picked. Next slide, please. The next slide talks about how these samples were prepared before they were sent to the lab. After they were picked using the core barriers, they were subdivided into subsamples, and after that, they were disintegrated and packaged for analysis. The analysis the analysis that was carried out was using the ICP-MS method. And next slide, please. That's the result of the analysis that came back. Yeah, that's the result analysis that came back, just displayed there. If you go to the next slide, it shows the chemical profile. Tells us about how this element and how each of these trace elements became down the depth over 30 centimeters. And one of the things that we noticed or we suspected is the fact that the different concentration of the metals down the profile inferred the abundance of metals that existed in the sediments that were deposited over time. So per time, the elements that were deposited informed the pattern we are seeing in the geochemical profile on your screen. Next slide, please. And then we attempted the metal association using Pearson correlation matrix and the R-mode factor analysis. Two factors were discriminated, and for the first factor, which is what you can see on your left-hand side, on your right-hand side, sorry. But yeah, we noticed that the elements there were possibly, most likely introduced by agricultural activities, industrial activities, and also indiscriminate dumping of waste. In addition to that, also exhaust fumes from automobiles might have contributed to the introduction of those elements into the environment. Also, for the second factor, which is just mainly zinc and cadmium, they are suspected to come from the waste dumps that are around the sample sites, the sites where the samples were picked.
Okay.
Next slide.
Could I ask you to conclude the talk, please? You're about a minute over now.
Oh, okay.
Yep.
And then we just went ahead to carry out environmental quality assessment, and then for conclusion, we were able to delineate that two metal sources rather might have introduced these metals into the environment, and like I said before, they were either industrial, agricultural, due to indiscriminate dumping. Thank you.
Great, thank you. Thank you for your talk. We'll make up a bit of time in the question and coffee session in a moment, and we'll come back to the schedule. Can we move to the next speaker, please? Have the next speaker ready, and then we'll have all the questions lined up in one go. Do please post your questions in advance on the chat room. Let's move to Salome Chilimo, please.
Okay, good morning and good afternoon, everyone. Can you hear me?
Yes, very clear.
Okay, my name is Salome Chilimo, a PhD student at University of Eldoret. My presentation is on occurrence and quantification of aflatoxin B1 in fish feeds in Kisumu and Uasin Gishu County. Next, please. Poor production and caring of feeds has increased the chances of aflatoxin formation. Aflatoxin accumulates in the food chain, hence causing both chronic and acute impacts to all animals. Both Kisumu and Uasin Gishu are the leading counties in agricultural production in Kenya. Hence, it's actually the center for fish feed production. Next slide, please. This study aimed at establishing contributing factors leading to mycotoxin contamination among farmers and fish feed traders, their effects and possible management strategies. A questionnaire and an observation checklist were used to collect data, and a cross-sectional exploratory study was employed where both qualitative and quantitative data was collected. Snowball technique was used to identify the respondents. Next, please. Fungal growth have been shown to be related to extreme weather conditions. And from this study, Kisumu County was found to be of high humid and relatively high temperatures compared to Uasin Gishu County. Maize, representing 49.7%, was actually found to be the primary ingredient in preparation of fish feed, with 83.3% being contaminated with aflatoxin B1. Most traders bought their feeds from large-scale manufacturers with an assumption that their feeds are safe. Yes? On storage practices and disposal of contaminated feeds, as you can see from the pictorials, most farmers and traders stored their feeds in poor conditions that are likely to influence growth of fungi. From the first picture, you can see there's poor storage, starting from the farmers actually storing their feeds on a dirty floor. The second picture there shows a multiple or a mixture of so many animal feeds which are mixed up, posing a lot of risks to even further contamination from other mycotoxins. You can see from the last picture is that some farmers were actually practicing sun drying as a way of reducing moisture content in their maize, but instead they dried in an open field on the floor that actually exposed them to more contamination. Next, please. Next. Next.
I think, Olivier, you need to go a bit slower. It's not showing up in Kenya quite so fast. You need to go back to the results page, I think.
Which slide do we want? Because it's...
Yeah, slide behind it. Yes, on prevalence of aflatoxin, okay. Out of 62 samples, 19.4% were contaminated with aflatoxin B1, with majority of the contaminated feeds were found from Kisumu County. Conclusion. Next, please. The type of ingredients used in production of fish feeds was determined to affect positively in the occurrence of aflatoxin. The amount of aflatoxin detected in the fish feeds increases the chances of bioaccumulation impacts in human health and also the fish. Therefore, I carried out the investigation as a preliminary study to actually understand the occurrence of aflatoxin B1, specifically in Kisumu and Uasin Gishu County. And the outcome will inform the preceding study, which will actually form the basis of its major purpose to find out the role of selenium in reversal of aflatoxin. And this will actually bring a solution to reducing or actually removing aflatoxins in some of the animal feeds. Thank you.
Okay, thank you. You're well within time. Thank you for your talk, and perhaps we can bring questions to that group of 4 presentations, please, Maureen. If we just take 5 minutes.
Okay. Thank you to all the presenters for your wonderful presentations. We have questions. We'll start with Sophia. I'll read the questions, then you respond. So the first one, Did you consider using other long-lived radioisotopes such as 129I? Then the second one from Koroba Elena. What is the level of variation of artificial radionuclide contamination within the study site?
So for this study, I'm mainly looking at radioisotopes which have been published previously around the world. So we're actually looking at 137 cesium, 239, 240 plutonium, which are both from nuclear weapons testing. And then finally, we're also looking at unsupported lead-210. These isotopes conform to quite a few strict restrictions on the analysis for the reference site to be able to be applicable for the study. We need very low mobility, and for the isotope that we're looking at to only be present as a spike in the soil. And then for the second question, that's actually what I'm investigating at the moment. So what I'm hoping to find is the amount of variation for the different types of radionuclide, to then be able to see which one would be most applicable to use for the future study. The hope is that because the radionuclides that I'm investigating were deposited over such a long time, that the effects of frontal rainfall will kind of be mitigated, and that the variation across the study site, which is quite small, will not be too great. So hopefully I'll be able to present in the future to answer that question more. Thank you.
Thank you. And a note to all presenters, kindly make your summarize your responses. Otherwise, you're doing great. The next question is for Job and Melvin from media. Have you considered what is the cause of erosion in the loam and clay soils? Are you planning to check the geochemistry of the soils as well? Job and Melvin.
Thank you very much, Lydia, for the question. We have not considered yet the cause of loam, but the main cause of loam and the clay erosion is plowing. That is human activity, farming, which loosens the soil. Then when it rains, it carries it over. But this presentation was just a presentation of a big project going on. It is an observational presentation. The geochemistry of the soil and sediments will be analyzed later, but this is what's going on in the field. We are presenting what we are seeing on the field. Thank you. Maybe Melvin can add something.
Okay. So concerning that, I would like to add that we are actually going to analyze both the potentially toxic elements and micronutrients composition and relate to the physical chemical factors of both water matrix and also for the sediments in the Winam Gulf of Lake Victoria. So we also are trying to understand the linkages between these anthropogenic activities and the results of this transfer of the micronutrients and toxic elements. Thank you.
Okay, 1 minute left for the last question to Nwoko. Nwoko, Maruzo is asking, do you have any data about trace element composition of groundwater? Hello, Nwoko, are you there?
Okay, don't worry. Let's. I think there's one other comment for Salome. I think perhaps if Nwoko comes back, you can answer in the chat room.
Yeah, we can chat. Okay, thank you. Back to you, Michael.
Okay, thanks. Thank you, Maureen, and thank you for handling the questions. It's quite tough for the first session as we get up to speed. So you're actually presenting in the next session, and Melvin Otieno will field the questions in the next session. So we are running over time. Could we ask that people come back for a start at 10:15? So we'll just start 5 minutes late according to the program schedule. Okay, 10:15. So that gives you 10 minutes to get a drink and a comfort break. Okay, we'll see you shortly.
Thank you.
Okay, just whilst we're waiting for everyone to come back, welcome Akira to SEGH. I think this is your first interaction. Before you start your talk, perhaps you'd like to just say a little bit about your society, the SIS, that when you approached me about a month ago.
Oh, hello. Can you hear me?
Yes, very clear.
Yeah, our society of about the study of iodine is not only for environment. It's mainly for the industrial aspect. So.
And the society is SIS, is it?
Yes.
Yeah, so if people Google SIS, they can find out a little bit more. Okay. Okay, I think we're ready to start with the presentation. I don't know if you're controlling the presentation, Olivier, or...
No, if Akira could please share his screen and we can start.
Okay, we'll start as people are coming back, and if we can try and keep to 12 minutes, and then we'll have 3 minutes of questions straight after this talk. Okay. I'll give you a warning about 2 minutes from the end, just as a reminder. Okay.
Okay, can see the slide?
Yes, we can see it. Yeah, and we can hear you very clearly.
Okay, let me begin. Okay, thank you very much for your kind invitation and introduction. Good morning and good afternoon, everyone. It's good evening here. My name is Akira Takeda from Institute for Environmental Sciences, Japan. I am very pleased to have the opportunity to present my research at this SEGHLive conference. Today, I'd like to talk about iodine speciation in soil. This slide shows an outline of my talk. Firstly, I'd like to give some background information on radioiodine, as already discussed in the previous sessions. Secondly, I'd like to introduce some iodine speciation methodologies we use. Thirdly, I'm going to show you some experimental results for understanding the iodine speciation changes in soil. Finally, I want to look at the iodine naturally accumulated in soil. Okay, let me start with the introduction of this study. As you saw the discussion in the previous session, iodine-129 is a long-lived radionuclide. One of the major anthropogenic sources of iodine-129 is in the environment is the reprocessing of spent nuclear fuel, as well as nuclear weapon tests. The first commercial spent nuclear fuel reprocessing plant in Japan, located in Rokasho, is preparing to full operations scheduled to start in 2022. With its operation, some radionuclides, including radioiodine, is released into the environment. A part of the iodine-129 discharged from the plant to the atmosphere is deposited on the land surface. Of course, radiation dose for public from these radionuclides is much lower than the natural radiation dose. However, people living near the plant are concerned about the fate of the radioiodine. Iodine is an essential micronutrient incorporated into thyroid hormones. Iodine in the environment occurs as several different forms of species, mainly as inorganic anion, iodide, and iodate. Organically bound iodine is also found in the environment widely. The mobility of iodine in soil depends on its chemical forms, so this dependence is important for better prediction of radioiodine behavior and better understanding of biogeochemical cycle of iodine. And it should be also useful for biofortification strategies for iodine deficiency. Now I'd like to move on to the iodine speciation methodology. We use the synchrotron-based technique for iodine speciation in soil, X-ray absorption near edge structure, so-called ZANES, was conducted in spring 8 in Japan. This graph shows the ZANE spectra. X-axis shows X-ray energy, and Y-axis shows normalized absorbance of X-ray. These are spectra of 3 different iodine reference materials: iodate, iodide, and organic iodine. We can distinguish these forms of iodine by comparing the spectra. Percentages of 3 forms of iodine in unknown samples can be evaluated by the linear combination fitting of each spectrum. We also conducted the speciation analysis of iodine in solid liquid phase. For iodine speciation in water sample, ICP-MS directly combined with HPLC system is the best technique with high sensitivity and high selectivity. But at this time, we needed another method for routine analysis for iodine speciation. We developed the HPLC system with a switching valve for simultaneous determination of iodide and iodate with the electrochemical detector and the UV with detector, respectively. Dissolved organic iodine can be evaluated by a subtraction of iodide and iodate from the total concentration of iodine in solution. Next, I want to go to the laboratory experiment. We collected soil samples from different depths in a coniferous forest near the spent nuclear fuel reprocessing plant. Surface soils from O horizon consists of later layer, and A horizon of mineral soil with high organic matter, as well as a subsurface soil from C horizon were used in the incubation experiment. Each soil had a different organic carbon content. Iodine was spiked to the soil as iodide or iodate to reach its concentration to 500 ppm. After 1 or 14 days incubation under room temperature and constant water content, the soil samples were analyzed by ZANES for iodine speciation analysis. In addition, extraction with the ionized water was also conducted to assess the extractability of spiked iodine from the soil, and the iodine species in the water extract were analyzed by HPLC. Let's take a look at the results of speciation analysis in soil. This slide shows the changes of ZANES spectra during the incubation experiment. Proportion of iodide, iodate, and organic iodine in the soil samples were estimated by the linear combination fitting of each spectra. When iodide was spiked to the soil, dominant forms of iodine in the soil were at 1 day after the addition is iodide. However, most of iodide changes to organic iodine after 40 days in the surface soils from O and A horizon. In contrast, iodide is still dominant in the subsurface soil from C horizon. How about the case of the iodide spiked soil? Iodide rapidly changes to organic iodine in the surface soils. In subsurface soils from C horizon, iodide did not change during the experiment at all. In both soils with iodide and iodate addition, the inorganic species rapidly changed to organic forms of iodine in surface soils, whereas original forms of iodine remains in the subsurface soils. The graph shows the extraction yield of iodine spiked to the soils. In the iodide spiked soil, more than 6% of iodine was extracted with water from the soils at 1 day after the addition. However, the extraction yield in O and A horizon remarkably decreased with time. On the other hand, water extractable iodine in the subsurface soils from C horizon did not change. Proportion of iodine formed in water extract are also shown as pie chart. It is clearly shown that formation of dissolved organic iodine caused the decreasing of the iodine extractability from the soil. This is the result of iodate spiked soil. Extraction yield was relatively low. However, the trend was similar to the iodide spiked soil shown in the previous slide. We plotted the concentration of the individual iodine species in the soil against concentration in the soils against the corresponding concentration in the water extract. The slope of the regression line for the organic iodine was more than 20 times the slope for the inorganic species. This result suggested that formation of organic iodine decreased the mobility of iodine in soil.
Okay, that's about 1 minute to go, if that's okay.
Okay, finally, let's take a look at naturally occurring iodine soil. We found a soil with very high concentration of iodine soil profile in a broad-leaved forest at another site. This soil has a 90 ppm of iodine. We analyzed this soil by Zanes, indicating that iodine accumulated as an organic form. This finding is consistent with experimental results previously shown. Okay, I'd like to finish with a short summary. Inorganic anions of iodine, iodide, and iodate were rapidly transformed to organic iodine in surface soil. This reaction considered to be proceeded via reactive intermediate species like molecular iodine, which easily bind to organic matter with carbon covalent bond. This transformation controls the iodine mobility and its accumulation process in soil. Thank you very much for your attention.
Okay. Wonderful, thank you. Thank you for your talk. I lost track of time for a moment there. I think we have a couple of questions. Melvin.
Yeah. Thank you so much, Akira Takeda, for your presentation. We have one question for you from Olivier Humphrey. It appears that the large majority of these reactions and conversions to OJ are most complete with 14 days. Have you got any plans to study these reactions over shorter time frames?
No, at present I don't have the plan, but I think the reaction is occurred in a much more shorter period. I think so.
Okay, I also have another question. Leaching of iodine contains organic matter dissolved in soil solution. So will this be an important source of organic iodine for groundwater and streams, in your opinion? And also, which soil properties are the main factors to influence the accumulation of iodine in the soil sample in the incubation experiment you had just mentioned earlier? Thank you. You're free to answer those as well.
Okay, for first question, iodine strongly fixed to the surface soil with high organic matter, but when soil lack of soil organic matter, iodine can be leached out easily from the surface soil. So, in fact, there are mobile forms of iodine can be found in the subsurface soils. And second question, could you repeat the second question again?
Okay, it's okay. We also have one question again. What is the motivation for processing the nuclear fuel waste in Japan? And is it for mitigating the effects of waste, or is it due to scarcity or nuclear material?
Thank you. It is very difficult situation, complicated situation in Japan, because 10 years ago we had a severe nuclear accident in Fukushima. So we don't have energy resources, so we need various energy source, including nuclear power. But power plant, it is unclear we can use power plants in the future. So it is argument whether we need or not, whether we need a reprocessing or not. So,
okay, thank you.
Okay, thank you.
Okay, thank you so much for your answers, and I will pass it over to Dr. Watts.
Okay, many thanks, Akira, for your interesting talk, and nice welcome to SEGH. Hopefully you stay with us, and hopefully we can have some links with your society. So we'll start the first batch of 4 presentations. So we're going to start with Elena Korobova, please.
Thank you very much. Do you hear me? Thank you very much for the opportunity to make a presentation at this conference. You see the title of my presentation. Please, next slide. Although thyroid goiter has been known since ancient time, earlier than in the middle 19th century, when Chatin has related this disease to iodine deficiency. And later, the natural factors of iodine deficiency contributing to goiter manifestation have been summarized. The Chernobyl accident of 1986 the problem of a combined negative impact of radioactive iodine fallout and natural iodine deficiency on the enhanced risk of thyroid cancer among children living in the affected areas. So the main goal of our research was to study and compare spatial distribution of thyroid cancer among urban and rural population of the Bryansk region subjected to Chernobyl fallout, with due regard to stable iodine deficiency in local diets using medical statistics experimental geochemical data, and modern geoinformation technologies. Next slide, please. The research background of this study was our investigation of oncology in urban and rural areas. And the difference in incidence of all types of cancer in urban and rural areas in the Russian Bryansk region was quite obvious in 2017, according to official statistics. And the recent publications and findings on thyroid cancer incidence rates among patients from urban and rural areas of the USA in the period at the beginning in the first decade of our century also showed this difference. So it was interesting to go on with our studies. The same was found in Canada. You can see it on the slide. Next, please. Thyroid dynamics in the Russian Bryansk region is presented here, and you see that Bryansk region demonstrated much higher thyroid cancer in all years after the latent period of the accident. Next slide. To study spatial distribution of thyroid cancer and its dynamics among urban and rural population, the medical database of all thyroid cancer cases registered in the Bryansk region from the time of till now was analyzed. And you see that on the left slide, on the left figure, that urban settlements, in urban settlements, the incidence of thyroid cancer cases within 5-year periods was considerably higher after the latent period. However, the mortality from thyroid cancer in rural areas appeared higher, and this is probably due to poorer medical care there. The next slide. We also analyzed the thyroid cancer cases in rural and urban centers of all the Bryansk districts. All districts are 27, and within most of them, in 24 districts, the incidence of thyroid cancer in rural settlements was lower than in urban, with the exception of 2 most polluted western districts, as you can see on the map on the right. We think that the case with this district is just because it is the less developed and populated, probably the poorest medical care there. Next slide, please. To evaluate iodine content in local products, we examined its concentration in the major local products in milk and potato and drinking water from available centralized and decentralized sources. The selected settlements for our study were located within areas of different radioiodine fallout, as you can see on the map. Next slide.
Okay, that's a minute to go. Okay.
1 minute?
1 minute, yeah.
When we compared the iodine concentration in potato samples and the spatial evaluation of natural iodine deficiency, you can see that there was really a tendency of correlation between the cartographic assessment of iodine deficiency and iodine content in potato samples. Next slide, please. Next slide, please. We also use the data on diet, on the structure of diet of rural population in Bryansk region to compare iodine consumption based on its content in major local products and in drinking water with thyroid cancer rate for rural settlements with population over 900 residents. And you see that the clear negative tendency between these parameters. Next slide, please. We also made a cartographic assessment of combined natural and pathogenic risk. This is the map of combined effect. The next slide, please. And thyroid rate in urban and rural settlements of Bryansk districts versus the cartographical risk assessment was also compared. Next slide, please. So conclusions, the analysis showed that in Bryansk region, which is contaminated by radioiodine after the accident, the incidence of thyroid cancer in urban areas is generally higher than in rural areas. The incidence of thyroid cancer in rural settlements tended to be negatively correlated with the level of consumption of natural iodine and positively correlated with a special assessment of the combined natural and man-made risk. In our opinion, the higher incidence of thyroid cancer among urban residents may be associated with the increased industrial pollution of these areas, of natural diet in urban conditions, and mishandling of certain chemical elements in the diet as completely toxic. We believe that geochemical factors deserve more detailed study when analyzing the spatial distribution of cancer among urban and rural populations, and we believe also that the results will help improve the quality of life in both settings. Thank you.
Well, thank you very much for your, yeah, it's very interesting. Thank you. We'll, if you can stay around, and we'll ask the questions after this group of 4 talks. If we can move quickly to ahead, Nazpur, please.
Hi everyone, I'm Mr. Nazarpour from Iran. My study is about urinary stones in Lorestan province, southwest of Iran. Lorestan, known as the land of the waterfall and the Karsi spring, that most of the people in this area use drinking groundwater drinking concern. Next, please. Next, please. In this study is a multidisciplinary study between chemistry, geology, and biological department in our university. This part we want to present mineralogy, geochemistry, carbon and oxygen isotope characteristics of urinary stone in Iran, case study in Lorestan province. Next, please. Here is my research interest about environmental geochemistry, GIS, and some programming in environmental studies. Next, please. In this study, the main outlines are a brief of history of urinary stones, material method, resultant discussion, XRD result, and SEM. Main elemental composition and major element, isotopic studies, and conclusion. Next, please. As you know, the urinary stone illness is the third most common complication among diseases of the urinary. Urinary stones have approximately 40 different compounds, and the most compounds are including calcium oxalate, phosphate, and uric acid. Zarasvandi present that percentage of patient with urinary stone in different area of the body varies between 20 and 30%. The frequency of urinary stone in lower in the woman than in the men. In general, changes in environmental factors have been associated with exercise and physical activity, hot and dry climate, and the diet program containing calcium, salt, low potassium, and favor excessive animal protein and alcohol. Present mineralogical study of the physical-chemical property of urinary stone in different parts of the world is most different that we compare or study with the other part of the world. The presence of the carbon isotopes and oxygen isotope in the human urinary stone is more helpful tool to determine eating behavior rather than other human tissues such as hair and urine. Next, please. The main purpose of this investigation to explore the environmental parameters, environmental factors, mineralogy, geochemistry, and the stable isotope composition in urinary stones of Lorestan province. Next, please. Here is in this slide we show that some part of or sample that that chemical analysis were carried out on these samples. Lorestan province is located in the Zagros mountain, the highest Zagros mountain range in Iran, south and west of Iran. Is a favorable climate. Lorestan is the mountain land and except a few plain. Most area of province are covered with a dense mountain and narrow valley in the Zagros mountain. Next, please.
That's 1.5 minutes. Okay.
Okay, thanks. In this study material method, including 53 urinary samples, 10 samples for ICP-MS analysis, 10 for XRD, 10 for XRF, and 13 urinary stone for isotopic analysis. Excuse me. Result of
I think we're having a few connection problems here.
Yeah.
600 of or sampled. Next, please. Do you hear me?
I think we're struggling with your connection a little bit.
Carry on.
Sorry about my this. In continuing of our study from geochemical analysis, thin section mineralogy was studied for this or sample by polarizonic microscopy we use for see the structure of urinary stone in the study area. Radial layers were observed in all of these samples with multi-nucleus that indicated that some geological feature and ecological and drinking water as an environmental factors could affect on urinary stone formation, and some light and dark layers indicated that multi environmental factor could affect it on these samples. Next, please. Excuse me for my internet connection. Or XRD test result indicated that most common minerals are including bedellite, uric acid, bevelite, uricide, and cysteine, and hydroapatite minerals. Next, please. Conversion or samples or sampled with other parts of the world, such as Sri Lanka and some Jordan and some cities in Iran, such as Khuzestan and Fars province, indicated that our sample related to hot and dry climate condition in some part of the Lorestan. In this part, we noted that we concluded that the main factor that affected on our chemical of our samples is biological and climate conditions, and drinking water, which could be able to formation of urinary stones. Hear me? Do you hear me?
Yes, we can hear you. Could I ask you to conclude, please, and summarize?
Okay, I can conclude that summarize my conclusion. Most SEM result, SEM. I will be thank you if you send a slide of SEM image. For brief, SEM studies indicated that the most common use of environmental.
I think we've lost him. You're still muted, Michael.
Okay, I think we're running over, so let's move to the next talk. It's just a shame he was just concluding there. And we'll move to Diana Menya, please.
Excuse me.
Okay, we thought we'd lost you. We're just moving to the next speaker. Okay, we can come back to you in the question session.
Sorry.
Okay.
Okay, I'm ready.
Is Diana there? Olivier, is Diana there?
I can't see her. If she is there, I can't see her.
Okay. What we may do then is just maybe allow Ehad just to finish his conclusions, and we'll skip Diana's presentation. Just 30 seconds, please.
Thank you. Next, please. The main conclusion or a study was SEM result. SEM result, and in general, 5 groups of calcium oxalate, urate, cysteine, phosphate, and the mixed stone of fluorescein was observed. Result of ICP-MS showed that the CA had the highest abundance compared with the other element, had a positive significant P2O5 and CaO and K2O. Conversion of the result in the study with other parts of the Kurdistan, Fars province, and the other parts of Sri Lanka and Czech Republic, Italy, showed that the main such elements are Ca, Mg, K, and potassium and sodium urate stone compared to the other region with have lower concentration. Next, please. Calculation of correlation coefficient for major oxide and trace elements show that the P2O5 and CaO are not significant associated with other, while MgO is positive correlated with P2O5. The positive correlation between Na2O and P2O5 is due to affinity of high affinity of alkaline metal for phosphate. The positive correlation between Na and Ca indicate the Na substitution for the Ca is due to similarity in ionic radius and crystalline structure. The average isotopic of oxygen and carbon and oxygen show that the Kindi stone can be some extent used for forensic research, since they provide information about the human exposure to trace element and the most common behavior in the Lurston area.
Sorry, Ed, I'm going to stop you there because you're well over time. All right. Thank you. We got a long way through your conclusions. We'll save some questions.
Thank you.
We'll see if we have Diana back. If Diana, can you make yourself known? Diana's there, but we can't hear you. We still can't hear you. There we go, we can see you. You had your thumb over the camera.
We're really struggling to hear you, Diana. don't know if we want to move on to
Shall
Daniel.
we go to Dan Middleton and then we'll come back to Diana when she's managed to sort out her camera? Okay. If you just mute Diana for now whilst we have Dan Middleton speaking.
Hello, can you hear me?
Yep, loud and clear. Off you go.
Okay, let me just figure out how to share screen. You see my slides?
Yes.
Okay, so good morning, everybody. My name's Dan Middleton from the International Agency for Research on Cancer. And I'm going to speak to you today about the IARC Monographs program. So the work of IARC is two strands which are intertwined. We generate data from original interdisciplinary research, including international collaborations, which I think we'll hear about from Diana. And we also evaluate evidence through independent expert reviews. And the IARC Monographs is an example of one of these types of reviews, which has been a program at the agency since 1971. So the IARC Monographs evaluations, so you may have seen these orange books. They are systematic evaluations which identify environmental risk factors which are carcinogenic hazards to humans. And hazard is an important distinction, not risk, despite what the title of the program used to be. So these agents include chemicals, complex mixtures, occupational exposures, physical agents, biological agents, and lifestyle factors. And these agents are classified into one of four groups, which I'm sure many of you have seen. So I've shown the groups here, and I've also given some examples of agents that you might come across in the geochemical environment. So group 1 is carcinogenic to humans. This includes 121 agents, including arsenic, nickel, chromium-6, cadmium, and all forms of asbestos. Group 2A is probably carcinogenic to humans. There are 89 agents in this group, includes nitrate and nitrite. Group 2B is possibly carcinogenic to humans, 315 agents, including lead and methyl mercury compounds. And group 3 is not classifiable as to its carcinogenicity. There are 497 agents in this group, including fluoride in drinking water, selenium and selenium compounds. So the monographs evaluations are conducted by working groups of invited or nominated independent scientists who don't have a conflict of interest, and they review the science and develop the evaluations. These working groups are supported by the IARC Secretariat, of which I'm a member of. So these are scientists who coordinate all aspects of the evaluation and ensure that the working group members adhere to the preamble, which is the guidance document which contains all of the procedures of the program. And there are other people that attend the meetings as well, but they don't draft text or contribute to the evaluations. So these could be invited specialists, so they're scientists that have relevant knowledge but a competing interest, representatives of government and health agencies, and observers who are scientists that have a competing interest, and they observe but don't contribute to the meeting outcome. So this could be, for example, representatives of pharmaceutical companies, different industries of agents that are being evaluated. So just to show a kind of overview of the pipeline of how these evaluations are conducted. So we identify the relevant information in publicly available databases of scientific literature like PubMed. And then papers are screened and organized, different studies are evaluated, and the study quality is evaluated. And then these characteristics and findings of different studies are reported. And then there's an overall synthesis of the evidence which feeds into the evaluations. And this is all done with the help of the preamble, which is the guidance document. And this contains procedural guidelines for things like participant selection, conflict of interest, stakeholder involvement, and meeting conduct, as well as criteria for the review of the different evidence streams, including human cancer, animal cancer, mechanistic evidence, which I'll talk about in a second, and then the decision-making process for the overall evaluations. And at the moment, this is all being done remotely because of the pandemic, so all of the meetings are done through Zoom. So the evidence that's considered in these evaluations comes in three streams. So these are epidemiological studies of cancer in humans, animal cancer bioassays, and then mechanistic studies of cancer biological mechanisms in humans, animals, and cultured cells. And then these streams are supported by another subgroup, which is exposure characterization in humans. And this is the subgroup which I currently work on. So just to show you how all of these streams of evidence are brought together. So each one of these evidence streams is given its own kind of sub-classification, which is sufficient evidence, limited evidence, inadequate evidence, or evidence suggesting lack of carcinogenicity. And then all of these individual classifications are brought together to give the final grouping. And that looks like this. So just to give the example for cancer in humans, because I don't have time to go through all of these streams. So for cancer in humans, sufficient evidence would be when a causal relationship has been established and chance bias confounding can be ruled out with reasonable confidence. Limited evidence is when causal interpretation is credible, but chance bias confounding could not be ruled out. Inadequate evidence would be when studies don't permit a conclusion or there are no data available. And evidence suggesting lack of carcinogenicity would be high quality studies covering a full range of exposures that consistently show no positive association at any exposure level. So how this would work in terms of deriving that final evaluation, if there's sufficient evidence for cancer in humans, that instantly becomes a group 1. If there's limited evidence of human cancer alone, that would be a group 2B. However, if there's limited evidence of cancer in humans and either or both sufficient evidence of cancer in animals or a strong mechanistic effect, that would then be moved up to a group 2A, which is probably carcinogenic in humans, but not quite enough to be group 1. So as I said, these evidence streams are supported by exposure in humans, which is the work of subgroup 1. And just to give you a quick overview of what subgroup 1 work looks like, the job of subgroup 1 is to unambiguously identify the agent being evaluated, describe its chemical, physical, biological properties relevant to its biological activity, describe key representative methods for analysis, so the different instrumentation used, the different detection limits of measuring these agents in different types of environmental, biological media. And then also describe production volumes, including historical production volumes of the agent and some of its common uses and applications. And then importantly, describe human exposure to the agent. So this includes reviewing studies on environmental occurrence, environmental monitoring studies, lots of which will be done by people in the society, review the regulations around the agent, exposure in the general population, and also occupational exposure, including reviewing studies of measurements of the agent in different biomonitoring and different environmental samples. And importantly, and this is a recent addition, the subgroup 1 experts also conduct a critical appraisal of the exposure assessment methods used in both the epidemiological studies and the mechanistic studies which feed into the overall evaluation. So experts in subgroup 1.
Dan, you have half a minute.
Okay, thanks, nearly finished. Experts in subgroup 1 include exposure scientists, epidemiologists, public health experts, industrial occupational hygienists, chemists, environmental chemists, analytical chemists, and last but not least, geochemists. So if you want more information on the upcoming meetings, please visit the website. We're always on the lookout for new experts. And just to say a big thanks to everybody who works on the program, including international collaborators, IARC staff, and our funders. Thank you.
Great, thanks very much, Dan. We'll come back to you for some questions. We'll be very quick on the questions at the end of this session. We'll see if we can get Diana back. Otherwise, we'll try and catch up with Diana at the end of the meeting. Do we have Diana? Okay. Olivier, whilst you're trying to get Diana online, shall we try the questions for the other speakers, for Elena and Dan? I think with Ahad we went way over time, so I'm afraid I'm going to skip questions for yourself. Melvin, do you want to field?
Yeah. Thank you so much, Michael. A question to Elena. What aspect of urban pollution do you think contributes to thyroid cancer? And also, Was there any biomonitoring performed alongside geochemistry and intakes, e.g. the urinary iodine? Those are the questions from the participants. Thank you. You're free to answer.
Okay, well, I just missed the question. Could you please repeat?
Okay, the question is, what aspect of urban pollution do you think contributes to thyroid cancer? And was there any biomonitoring performed alongside geochemistry and intakes, for example, the urinary iodine?
Thank you. As for, sorry, this is my office call. Well, for urban, I think that any disturbance of natural diet that interfere their relation between iodine the normal iodine content and in food may affect. It doesn't matter whether it's a rural area, in fact, but the most significant element is, of course, selenium that Dan Middleton has already told. And any other pollution, I think, could be studied. As for urinary investigation, yes, we also use the medical data on iodine in urine of among local population. This study was performed by a medical center in 1994, 1998. And we found a correlation between our risk assessment and iodine in urine of the in children from 1 to 3 years old, but not for the other groups.
Okay, thank you so much. Due to time, I would just like to request Dan Middleton to share the link to the organization to the chat box so that anyone interested can have a look at it in details. Thank you. I'll hand it over to Michael.
Okay, thank you. I think, Olivier, we're struggling with Diana still, aren't we?
I think Diana's now connected to a different microphone, so I've just asked her to unmute so we can test that.
Okay. Otherwise, we'll move on to the next session with Martin Gabasek. So if he gets himself ready, just in case.
Hello, can I be heard now?
We've got you, Diana. Yeah.
You can hear me?
Yeah. Okay. So your slides are on screen, Diana. So if you could start, please.
Okay. Thank you very much, Michael. Let me ask again, can you hear me?
Yes, very clearly.
Oh, great. Thanks. So that is the title of my presentation. I was very happy to see in the earlier presentations, there was one about fluoride levels in western part of Kenya. So I'm going to present the human aspect of it. So next slide, please. Cancer of the esophagus is a devastating condition whose 5-year survival rate is extremely low, even in the best centers in the world. It is the third most common cause of cancer deaths in Eastern Africa, and it has a unique worldwide distribution as shown on this map. Just note the map of Africa and look on the eastern side where the incidence of esophageal cancer is very high compared to West Africa. So the multiple causation of this cancer is very complex. It's a complex interaction between host, environment, and perhaps an unidentified agent, which is widely present in the cancer corridor along the Great Rift Valley. Next slide. In 2014, we began a case control study in collaboration with the International Agency for Research on Cancer. The third phase of this study is still going on. The objective of the study was to determine lifestyle, behavioral, and environmental risk factors associated with this cancer in Kenya. The study participants were patients suspected of having esophageal cancer who presented for endoscopy in our teaching and referral hospital in Eldoret, Kenya. Those consenting to participate in the study underwent an interview after the endoscopy procedure. Biospecimens were collected and a thorough oral examination was carried out by our research assistants who had been trained by our study dentist. They recorded cases of leukoplakia and DFMT, which means decaying filled and missing teeth, and also cases of fluorosis in the teeth that was talked about this morning. So the cases were endoscopically confirmed esophageal cancer, cases of whom 90% also had histological confirmation of esophageal squamous cell carcinoma. Adenocarcinoma was excluded from the analysis. The controls were frequency matched by age and gender, and the study, of course, had ethical approval from Kenya and from international agency. So here I'm going to present results of oral health associations and the risk of esophageal cancer. The odds ratios were adjusted for tobacco, alcohol, ethnicity, and other factors, oral hygiene, missing teeth, and so on. Next slide, please. The results showed that overall, esophageal cancer had, the cases of esophageal cancer had poorer oral health and also oral hygiene than the controls. Compared to no fluorosis, moderate and severe fluorosis had crude odds ratio of 20.8. This is really high and it alarmed us, but on full adjustment, it was associated with a 9.4-fold increased risk, which are still very high odds ratios. Mild fluorosis had an adjusted odds ratio of 2.3. So increased cancer risks associated with moderate and severe fluorosis were particularly strong in individuals who had tooth loss and decay. Further, the use of traditional toothbrushes called mswaki rather than commercial toothbrushes and infrequent brushing of teeth independently increased the risk of cancer. Next slide. In conclusion, poor oral hygiene and fluorosis due to consumption of water high in fluoride levels in the Rift Valley region appears to be a risk factor for this cancer. The associations we have reported require further investigation, especially in relation to mechanisms. For this common and highly fatal cancer with very limited treatment options in our settings, prevention becomes very important. In order to prevent the cancer, we have to identify the risk factors associated with it. And that is the focus of much of our research. For more information on this topic, next slide, I would like to refer you to one of our publications, which is in the International Journal of Cancer. Thank you.
Wonderful. Thank you very much, Diana. I think, Melvin, you have a question for Diana.
Yeah, there is one question from the participants. Why should the use of Miswaki toothbrushes increase the risk of cancer? So perhaps you can even elaborate to other audience what Miswaki is. Thank you.
Okay, thanks, Melvin, for conveying that question. That's a Swahili word actually for toothbrush, and it's a traditional toothbrush that is made from a branch of a tree. You just go and pick up a bit of a tree, and it's not any tree. I think it's a special tree for brushing your teeth. So it seems the results of this study are showing that perhaps with this particular type of toothbrush, you're not cleaning your teeth as well as you would with a commercial toothbrush. And that results in poor oral health, which we are now showing is associated with esophageal risk, the cancer of esophageal cancer.
Thank you. Thank you so much. One final question. Does that mean that fluoride is geogenic in source?
It could be, you remember in the earlier presentation that was given by a colleague of yours from Kisumu, she stated and she also showed maps of where fluoride is common, and the Rift Valley is one of them. And she also alluded to the Rift Valley area, the volcanic soil and so on. So I think that it could be that whatever fluoride is present there gets into groundwater, and then people drink this groundwater and then have fluorosis, as was said this morning, which affects the teeth and the skeleton. And she also alluded to the fact that it is found at the floor of the Rift Valley, which in our case, that was the situation. And in the highlands, where people drink surface water, the fluoride cases are not that high as they are on the floor of the Rift Valley, where the fluorosis cases are high, and also the cases of esophageal cancer are high. But also let me say that the causation of this cancer is multifactorial. It's a combination of many factors. So I'm not here to say that it's only fluoride that causes this cancer. It is a contribution from many other factors, and in other publications that we have shown that alcohol and tobacco and drinking of hot beverages is also associated with cancer, and we have published this work. So again, I'd like to underline the fact that the causation of this cancer is multifactorial, and we need to study it further. And the issue of fluorosis, my team, and now maybe I'll get collaborators from this group willing to look further into this particular risk factor for esophageal cancer.
Okay, thank you so much. I'll hand it over again to Michael.
Okay, wonderful. Thank you very much, Diana. I'm pleased we managed to get you online.
Thanks.
And thank you for the group. We're running behind on time. We may make up some time in the question sessions later in the closing comments and SEGH discussion. So can we move to Martin Gambasek, please, who's going to start us on the next 4 presentations.
Hello to everyone. Nice to see you again. Today I'm going to present you briefly some results on our study of chemical and morphological characteristics of household dust. Next slide, please. The household dust study was part of a larger geochemical study of urban environment in Maribor, in Slovenia. In this study, we analyzed various media from soil, street dust, attic dust, household dust, airborne particulate matter, and snow. Household dust was sampled by collecting vacuum cleaner bags. We collected 27 samples. In 2 cases, we collected samples from 2 different apartments in the same residential building. Participating residents also completed a questionnaire on their lifestyle, habits, and the characteristics of the apartments that could influence the characteristics of household dust, like smoking, frequency and type of cleaning, type of heating, presence of pets, and so on. We determined levels of 65 elements on size fraction below 63 microns. And chemical composition was determined by ICP-MS after aqua regia digestion, and selected samples were analyzed also with scanning electron microscope with EDS. Next slide, please. In this table, we have examples of minimum, maximum, and median levels of some of the analyzed elements, and distribution of nickel and lead levels in each samples are given in these 2 graphs on the right. The main finding of the chemical analysis is that the chemical composition differs strongly from one apartment to another. Differences occur also in different apartments in the same residential building, which is clearly shown with an example of nickel. These 2 red markings on the graph denote samples from 2 apartments in the same building. The ranges of levels of most elements are also quite big. And all this indicate that potentially toxic elements and other elements mostly originate from specific sources within apartments, and the influence of external sources is less important. If we compare chemical composition of soil, street dust, attic, and household dust, we can see that out of 65 elements, silver, gold, barium, potassium, and sodium have the highest median levels in the household dust. Next slide, please. Then we analyzed selected samples by scanning electron microscope with EDS to determine morphological and chemical characteristics of individual solid particles in household dust and try to determine their sources. We focused on potentially toxic element-bearing particles. And almost 20% of PTE-bearing particles in household dust are represented by barium sulfates, often with zinc. And one example of such particles here on the left side. And we believe that this type of particles originate from the degradation of white wall paint. The high sodium levels were connected with the use of table salt, and one example of natrium, I apologize, of potassium chloride is given here on the right. Next slide, please. And another interesting particle type in household dust are spherical particles consisting of iron, cerium, lanthanum, and oxygen. Their occurrence coincides with the highest levels of cerium and lanthanum in the dust. We found out that these spheres occur in apartments in which residents regularly smoke. These are all these apartments marked here with red arrows on this graph. And these spheres do not originate directly from smoking, but from the use of lighters. Next slide, please. Yeah, that was briefly about our study, and more information about household dust characteristics and particularly its comparison with other media is given in this freshly published article. So thank you for your attention.
Wonderful, thanks very much. We'll come back to you for questions in a moment, okay? So if we move to Kiri Rogers, please.
Thank you very much. Hi, so some of you may know me. I kind of disappeared for a wee bit, but I've come back and I'm actually starting research. So what I'm going to talk to you about today, I will be as brief as possible. But it's a new project that we're taking on, and it's basically tackling antimicrobial resistance across India. So over the next few years, the University of the West of Scotland and the Indian Institute of Technology and Biotechnology, as well as the Ministry of India, is actually working together to see if we can actually find a way of mitigating antimicrobial resistance. Although we're focusing on India, it's more of a global pandemic. So next slide, please. So for those of you, I'm sure, are very aware of antimicrobial resistance. It's definitely one of those things that's becoming more and more prevalent in the news. Granted, obviously, COVID is taking quite a spotlight at the moment, but it's definitely something that we need to be concerned about, especially when trying to look at all the different variables. And something that has become very apparent recently is the fact that we need a One Health approach. So this slide is really just depicting the fact that it's not just about the science or on its own. It's actually talking to everyone on an economic, psychological, worldwide, but also how do we relay that between everybody so everyone's research is collaborated and actually combined so we can get the best results ASAP, I guess. Next slide, please. Brilliant. So what do we know so far about antimicrobial resistance? So previously, which at some point I'm sure I will share the research results finally for this, we know that there are a ton of variables that actually affect antimicrobial resistance. Although pharmaceuticals and the use of antibiotics is the prevalent or most obvious factor, in more recent years, there's definitely an interest basically saying that we're not even just looking at that. We've got things like the farming industry, but also pollution, which is really where my interest comes on a geochemical scale, where we're looking at things like heavy metals and PAHs, and how that then can impact different strains, whether that's environmentally or then taking into a clinical setting. And then obviously one thing I want to highlight is the economic impact, because obviously if we can't treat even the simplest of illnesses, which I think by 2050, they reckon we're not going to be able to even just help ourselves with the flu, which is a very, very scary thought, because it means that death rates are going to soar. But the economic impact of that is massive. And also it was an economist, God, I can't say that word, that actually brought this to light in 2014, basically how worried we need to be. Next slide, please. Thank you. So basically, this slide is really just highlighting what we know so far, or where our interests of focus are going to be from what I've said. So we're going to try and combine geochemical and metagenomic analysis, but we're also going to use general geochemical analysis independently, as well as look in the microbiome, whether that's in situ or out of situ, or actually, as I said previously, in a chemical setting. Next slide, please. Just to end on something really crazy and huge. Although I'm saying all of this, this is a summary of our actual group and the title of what our research is going to be for the next 3 years, which is Advances in Metagenomics, Sensors, Photocatalysts for Antimicrobial Resistance. But what this is highlighting is actually a split where we've got 4 main aims between ourselves and our Indian collaborators. But also I want to highlight that this isn't just scientists. I mean, we've got social scientists, we've got psychologists, we've got economists. We actually have a very broad range, and that also includes people that are going to be policymakers and legislation dictators, which we are hoping to ultimately influence. Obviously, this is a very, very brief, this is what we're going to do, this is what we're hoping to do. With COVID being so delayed, everything's on a bit of a standstill. But what that has also meant is collectively what we would like to do, and have actually got something started in Scotland, is actually do some smaller grants working with smaller groups looking at antimicrobial resistance, whether that's in soils, waters, farms, all different environments, but across the whole of the UK. So I guess part of me is going, this is also a pitch. If anyone is interested in a bit of side research while you've got time to kill, that would be wonderful. That's all. So thanks very much for listening, guys.
Great, wonderful, perfectly on time. Thank you. We'll come back to you for questions in a moment. Okay, so can we have the next speaker? I'm going to try and pronounce your name. I do apologise. Nana Efahubo. Can you correct me, please? Do we have the next speaker online? Can you see the next speaker, Olivier?
No.
Okay, well, we'll try and get them back later. Shall we move straight to Daniel Nietsch then, please?
All right. Hello, everyone. Thank you for giving me the opportunity to talk here today. I'm going to talk briefly about the project I was undertaking during my PhD at Manchester Metropolitan University. Starting off, next slide, please. Starting off with a little bit of background, air pollution and poor air quality is linked to severe human health impacts, resulting in approximately 40,000 premature deaths annually within the UK. And nitrogen dioxide in particular is linked to cardiovascular and respiratory diseases. Next slide, please. So how is the air in Manchester? Well, given its industrial heritage, Manchester has been known for its poor air quality and is still ranked highest in premature deaths related to respiratory and cardiovascular diseases. And according to UK guidelines, 2 automated monitoring stations provide continuous data for airborne pollutants, such as nitrogen dioxide. And on the figure on the left, you can see that it often breaches the regulatory value of 40 micrograms. Next slide, please. So as part of my PhD, which was mostly or primarily lichen biomonitoring study, we used passive diffusion tubes to ground truth the lichen data, but also to assess spatial and temporal detail or finer detail of nitrogen dioxide concentrations across the city center area of Manchester. So at 45 sites out of 94 lichen sampling sites, tubes were deployed over a 12-month period and were changed on a bi-weekly basis. Next slide, please. So looking at the temporal variability, we see that we have a nice seasonal variation of nitrogen dioxide concentrations with consistently higher NO2 within the city center area. Particularly during colder months, we have elevated nitrogen dioxide concentration, whereas during warmer or more summery months, we have lower nitrogen dioxide concentrations, which is most likely related to photochemical oxidation of NO2. Next slide, please. Comparable to that, the spatial variability was also recorded. In this figure, you can see the mean concentration over the 12-month period at each location site. And again, the city center shows elevated nitrogen dioxide concentrations, but also along the major road network. Interestingly, also in more open and more residential areas, we could see elevated nitrogen dioxide concentrations. So next slide, please. So we used some of the available data sets for Manchester, like major road distance, building heights, and traffic count data, as well as road class, to assess potential urban influencing factors on the recorded nitrogen dioxide concentrations. And on the right, you can see in red that particularly in close proximity to highly trafficked roads, we have high nitrogen dioxide concentrations. Whereas on the left, you could also see that there is a potential impact of the urban surroundings, so having elevated concentration of NO2 within more densely built up areas. Next slide, please. If we go from an angle of a human health perspective, this figure shows the times each location breached the regulatory value of 40 micrograms. Particularly one site exceeded this value 22 times out of the 24 consecutive measurement periods, whereas only one site did not exceed the value. Again, even within more open areas and or more residential surroundings, we could see breaching of these limits. So this shows that both monitoring stations, although providing continuous data, do not assess the finer spatial detail of nitrogen dioxide across a wider area of Manchester and potentially underestimate the human health impacts. Next slide, please.
You've got about half a minute to wrap up.
Just to wrap up everything, as I just said, both monitoring stations provide continuous data. However, it's necessary to use cheap and fairly quick methods to assess air quality and finer detail. And for Manchester in particular, vehicular emissions were found as primary cause, but also an influence of the complex urban surroundings. And we had highest NO2 during cold episodes. Thank you very much for listening.
Great, thanks very much, Daniel. We'll come back to you for questions in a moment. Are we able to get our last speaker back, Olivier? Do you know?
I'm not sure if they're on the chat, could they make themselves known? I'm not sure they are.
Okay. Whilst we're just waiting for that, perhaps Melvin, you could field some of the questions.
Yeah.
Thank you, Michael. I have a question for Martin. Are there plans to assess the inhaled dust? And also, was the household dust collected using a specific protocol, or did you get residents to send it in? And the last one is, were there any correlations investigated between metal concentration in house dust and questionnaire data?
Yeah, we have already done ingestion bioaccessibility test, UBM. And we plan to do also UBM on smaller dust fractions in the future. And of course, inhalation bioaccessibility would also be very useful thing to do. About the next question, we didn't use a specific protocol, but the only thing we asked the participating residents was to vacuum only in apartments, in residential part of their homes, not in workshops or garages. And about the last one, no, not yet. We didn't calculate correlations with statistical tools. For now, we only found out the most obvious one, like this smoking apartments and high lanthanum cerium levels and these spherical particles. I think that's all.
Thank you so much for your answers. Another question is for the previous speaker on antimicrobial resistance, that is Kiri. One question for you is that how much does environmental pollution contribute to antimicrobial resistance in bugs, giving human diseases?
You know that way I really want to go, Alex. Really good question, but probably a researcher needs to carry that out. No one, it's not something that's been massively looked in. I think because there's so many new avenues that people are exploring, the sky's the limit of, sorry to say, no idea, never ending unknowns.
That's a very big question. Yeah.
It's okay, thank you. Okay. I'll hand it back to Michael.
All right, thanks, Melvin. I think I'm going to have to assume that we are not going to recover the talk from earlier from Nana. So, unless you say otherwise, Olivier?
No, I don't think so.
Okay, so let's move on to number 17 in the program. Okay, Zacharina Kipritidou, can you please pronounce your name to correct me?
Yeah, it's all right. Can you hear me?
Yes,
okay. Okay, I'm Zacharina Kipritidou from the University of Athens, and our study involves the immobilization of toxic metals in mining soil using natural clay minerals. Next slide, please. So it is known that the interactions that occur in the clay interface are controlling the mobility of potentially toxic elements in clay-amended soils. So the aim of our study was to compare 3 bulk clay materials regarding their stabilization efficiency. Next slide, please. The clay-amended used was a palygorskite-rich clay, an iron smectite-rich clay, and a natural mixed palygorskite iron smectite clay. The clay amendments are natural materials collected in the field, so they also contain various other mineral phases. The soil was collected from a Stratoni mining village in North Greece, which is mildly contaminated with lead, copper, zinc, cadmium, arsenic, and antimony, and is also mildly acidic. The experiments involve the mixing of the clay amendments with the contaminated soil in different proportions, watering of the mixtures for a month, and the estimation of the water-leachable PT concentration as well as pH. Next slide, please. The results showed that the stabilization of the elements in the amended soils increased with increasing the clay proportion, as well as pH of the mixtures increased. The high retention efficiency was observed when 7% of clay amended was used, especially in the mixed clay material compared to the palygoscite or iron smectite relatively pure amendments. So the stabilization efficiency for the 7% clay treatments was calculated using partitioning coefficients between the solid and water and liquid phase of the elements. This showed that lead was stabilized about 80%, copper, arsenic, and antimony were stabilized at about 60%, and cadmium and zinc about 50%. Next slide, please. The clay amended soils were also classified according to the EU directive for waste disposal. So we see that before the treatments, the soil was classified as a non-hazardous waste due to the elevated lead and arsenic concentrations, whereas at the 7% of clay treatments, the water leachable concentration were as low as the soil to be classified as inert waste for safely disposal in the landfills. Next slide, please. So the superiority of the mixed clay material in stabilization of potentially toxic elements in the amended soils was assessed regarding its physicochemical properties. You see that compared to the palygoscite or the iron smectite rich clays, the mixed clay material contained about equal amounts of palygoscite and iron smectite, which gave it high cation exchange capacity as well as specific surface area. Both properties are significant for the stabilization of potentially toxic elements by the clay surfaces. Next slide, please. So as a conclusion, we can say that all three clay amendments were able to stabilize the potentially toxic elements in a contaminated soil. With the mixed clay material show the highest stabilization efficiency due to the coexistence of different clay phases with different physicochemical characteristics. However, the mobility of potentially toxic elements in clay amended soil is not only controlled by the properties and physicochemical characteristics of the clay amended applied, but also of the primary properties of the contaminated soil amended, such as mineralogy, texture, pH, etc., as our recent study has shown. Next slide, please. Thank you very much for your attention.
Wonderful, thank you. Perfectly on time. If you could wait with the others for some questions at the end of this session, and we'll move on to the next speaker, please. Maureen Ondayo. Do we have Maureen?
Sorry, I'm here.
Okay.
Thank you for the opportunity to present. My name is Maureen from the University of Eldoret, Kenya. And here's my topic of study. Slide 2, please. So, globally, there's been a long history of mining, with the bulk of it being artisanal and small-scale mining. So, our research focuses on artisanal and small-scale gold mining in Kenya, and you're looking at the environmental exposures, the human health, the human exposures, and the possible health impacts. Next slide, please. Okay, a typical artisanal and small-scale gold mining involves use of low rudimentary technology, and the miners are generally unskilled. So it means there are no pollution controls and any safety measures. So there's a tendency of toxic elements, potentially toxic elements to be released into the environment. Next slide, please. So here are photos here showing typical processes within my study areas in Kakamega and Vihiga. They're located in Western Kenya. Here is after digging the ores from underground, the miners crush them into smaller pieces. That's in the first picture. Next slide, please. Then after crushing, they are ground using these machines, which release a lot of dust. The previous slide, please. Yeah. So after that, women and other people wash them alongside streams and within the ponds. Like here we can see there's a young pregnant woman here doing the washing, no protective gears. Then we are seeing here a young schoolgirl using mercury to collect the gold from the ores. Then this is the final sluice waste, and I have other pictures showing that it's directed to a pond. So this is what happens. Basically, there's an environmental exposure, and of particular public health interest is the exposure of these PTEs, the potentially toxic elements, to the miners and the local communities who are not aware of these. Next slide, please. Next one. Next one. Okay. So these activities in Kakamega and Vihiga have been going on since 1930. So that is over 7 decades, almost a century. So the areas are densely populated, and there's a likelihood that the communities are continuously exposed. So we have evolving environmental health and safety regulations here. So they're not stringent as such. So that is what prompted this research. So we also have data gaps. So we are hoping that after the research, we'll have data that will inform decision making for the regulators. So next slide, please.
Okay, you have just over a minute. Okay.
Oh, okay. So we are evaluating the environmental and human exposures, and you're also evaluating the mitigation technology so that we can advise and train the communities and the workers. Next slide, please. So our preliminary, next please. Our preliminary results. Next, the Word document. Our preliminary results indicate that the Word document, please, indicate that we have the PTs are present in the environment, and the values are exceeding the respective WHO threshold. So this one means that the ongoing artisanal and small-scale gold mining activities could be posing a risk to the workers and the unaware communities. So it's an ongoing research, and we'll share more as we progress. Thank you.
Okay, thank you, Maureen. I think your Word document wasn't possible to open for your results.
Sorry, I wasn't able to get that.
Yeah, don't worry. I think you summarised some of the data, so perhaps some questions will come through later to ask you in more detail about that, some of your findings. Thank you. Can we move to the next speaker, please? I think Temitope Lanyan. Oh, I think.
Yeah, good day, everyone.
Hello. Welcome.
Thank you. I'll be presenting a work on the effects of artisanal mining on children in Anka, northeast Nigeria. Next slide, please. Next slide, please. Thank you. Now, artisanal mining from the former presenter has showed that it has a lot of health impacts because it releases metals, potentially toxic metals that could be of health risk to both man and children. So our focus is particularly the effect it has on children. The study and geology, the study area was done in Anka. That's the map of the area, and Anka is underlain by Precambrian migmatitic gneiss. Next slide, please. Next slide, please. Well, materials and method. Now, a total of 40 samples. No, next one, please.
There may be a slight delay. I'm currently showing the materials and methods first slide.
Yes, okay, thank you. A total of 40 samples were taken from both boys and girls, 20 males and 20 air sample. This was done after it had been approved even by the local government of the area and after following different procedures, and several air control samples was also picked, and it was placed on analysis. The results of the water, because we are correlating it with water, soil, mining, tills, and plants of the area, show that most of the elements in the area are above the standard, the permissible standard. Next slide, please. Okay, so for the result of groundwater reveals that most of the elements are high, they are above the permissible sample, and that of the soil also revealed that. Next slide, please. The air and samples that were taken by the air and fingernails samples were taken from boys and girls, and control samples. All these samples were correlated, and the interesting thing revealed that air samples of girls has higher potentially toxic metals compared to that of boys. Maybe it could be due to the way girls use oil to rub their hair, and it allows metals to stick more on them. But the fingernails of the boys, it has higher heavy metal compared to that of the girls. Next slide, please. The metal samples of the boys and girls were correlated with that of the soil, and it revealed very high metals in the air and the nail of boys. That which also reveals that these boys and girls, the metal gets accumulated in them from the environment. Next slide, please. Yeah. Next slide, please. This was to show the source, the main source where these metals could come from. From the diagram, the red is showing the mining activities, and the blue color is showing the mixed source. So most of the metals that were on the nail and in the air of both boys and girls were from the mining activity. This really shows that artisanal mining, illegal mining, has a major health risk on both adults and children in particular. So from the discussion, next slide, please.
Okay, 1 minute left, please.
Yeah, I'm concluding now. Next slide, please. Next slide, okay. Now, the metals in the nails of boys were found to be higher than that of the girls, and this revealed that boys could be more exposed to mining activity than girls. In conclusion, I'll say that heavy metals accumulate more in the nails and hairs of children in the area than even in the blood, as reported by Odabiele. Heavy metals in hairs and nails of the children originated from mining and mining processing activities. So it will be recommended that total remediation program should be done in the area to avert major health impact on the children, and inhabitants of this area should be educated on the health problems associated with heavy metals bioaccumulation. Next slide, please. Thank you. Just want to acknowledge the work that was granted. Thank you.
Wonderful, thanks very much. If you could stay around for questions, we just have the last talk coming up for Voter Kettler, and then we'll pull all of the questions together for you as a group.
Hello, good afternoon. Greetings from snowy Prague. Okay, today I will speak about slag dust from Kabwe in Zambia, and I will focus on contaminant mineralogy and oral bioaccessibility. Next, please. Okay, this is a Google map of Kabwe, an old lead and zinc mining and smelting site. This area has been ranked amongst the 10 worst polluted places on Earth, especially due to extensive intoxication of local inhabitants by lead. On this map, you can see the black areas, which are in fact large slag disposal sites. Next, please. And this is how the slag materials look like on the heaps. Next, please. The Kabwe slag dumps are sources of particulates, which in fact cause extensive soil and air pollution in the area. Unfortunately, the area is not fenced, so people can go there. They are digging for lead residues, which is then sold for recycling. But the main problem is that it is a playing ground for kids. Next, please. You can see how the dust adheres to their hands and legs. So we wanted to know if there is any risk related to incidental dust ingestion, especially dust originating from these slag dumps. Next, please. So we used 2 slag dust fractions, less than 48 microns, which is the material which can adhere to hands, and then less than 10 microns, which can potentially be inhaled. But of course, part of this fraction can be swallowed and can end up in the gastrointestinal tract. These materials have high concentrations of metals. Next, please. And we did quite quick bioaccessibility testing protocol. We used a simulated gastric fluid, a highly acidic solution, and these extractions have been combined with mineralogical investigation and frequency geochemical modeling. Next, please. The materials are quite complex in terms of mineralogy. So you can see on these CM photos that it is very complex. Main metal carriers are slag glass and various secondary weathering products. Next, please. The bioaccessibility testing indicated that bioaccessible fractions are very high, going up to 100% of the total concentration. We assessed 2 exposure scenarios, calculating with the dust intakes of 100 milligrams per day, which is quite conservative, and with 280 milligrams of dust per day, which is more realistic at this site. This graph shows intake of lead per day, calculated for different slag materials and different fractions. And in both cases, you see that intakes of lead highly exceed tolerable daily intake limits, which are defined for children and adults. And you can see them on the right side of the graph in the red color. Next, please. So you can see that lead exceeds up to 500 times tolerable daily intake limits here in this case. Next, please. And of course, other contaminants can be also problematic, especially fine fractions, and if you consider children as the targets. Next, please. I will not repeat the main results in the conclusions. I will just say that the slag dusts in this area represent a real risk, and that remediation action is highly needed. Especially the area should be fenced off to prevent local people from entering. Next, please. And if you can, of course, you can read more in our paper, which has been published last year in Chemosphere, which is open access, so available to everyone. And next, please. So I will thank you for listening, but I have one more slide, okay, which is, so if you can put the last slide of my presentation. Next, please. Okay, this is just a little advertisement, okay. You probably understand that slag materials are my favorite materials. Okay, so we have just finished a book which is coming soon, entitled Metallurgical Slags, Environmental Geochemistry and Potential Resource Potential, which has been edited by Nadine Piarak from United States Geological Survey and me. And this book will be available probably in the summer of this year and published by Royal Society of Chemistry. So you are free to buy it in coming months. Thanks a lot for listening.
Great, thanks very much. We'll come back to questions in a moment. We just have the speaker from earlier, so that's presentation number 15. So that's Effie has just got in touch to say they're available to give their talk. Is that possible? Olivier, Effie, can you make yourself known online? Otherwise, we're going to need to move on because time is marching on for the meeting.
Are they there? Are they available?
They just sent me a
Good
message.
afternoon, everyone.
Hello.
Good afternoon, everyone. My name is Efe Bunana. Yeah.
Okay, go ahead.
Good afternoon, everyone. My name is Bunana. And I am doing a presentation tied to the health risk assessment of lead, copper, and zinc in road dust from Shagam, Southwest Nigeria. Next slide, please. Next slide, please. Next slide, please.
Yeah, I think it's taking a while to show on your screen. So Olivier, you might have to say when you're changing slides and tell him which slide you're on. I think we've lost him. Yeah. Okay. I think we'll need to cut that talk then, Olivia. I think the signal's too weak, and we'll start having people leaving the meeting if they can't hear him. So can we go to the question session, Melvin, for the previous talks?
Okay, I have a question for Zekaranya. Apart from the positive results regarding stabilization of contaminated soils, are there any data on whether the wide application of any of these clays is financially viable for restoring contaminated areas? And from the 3 clays, which one will be the cheapest to use on a bigger scale?
So all 3 clay materials used are natural materials that require less reprocessing to be applied as amendments, and they are all of them are equally cheap compared to other materials that may be applied, but there is no significant difference regarding their cost.
Okay, and what is it about the zinc and cadmium which makes them more immobilizable by the clays?
Zinc and cadmium were less immobilized by the clays compared to lead and copper. And this depends on how zinc and cadmium are in the primary contaminated soil, the form they are present in the soil, and their relative amounts. So because they are less in the soil compared to lead, they are less stabilized because lead is preferentially stabilized in the soils by the amendments.
Okay, thank you so much for your response. My question will go to Maureen and Lanian, since it seems that your research work is sort of similar, but the case studies are from different countries. So mining damages health in many ways, including dust, chemical spills, harmful fumes, and heavy metals and radiation. Are you conducting a full environmental public health study? Maureen, you're on. You can unmute yourself.
Sorry, thank you for the question. I would like to respond to that. For me, I'm doing a complete environmental public health studies, whereby from the source, I'm looking at almost all the migration routes, like now the soil, the sediments, I'm looking at the water, I'm looking at the food, the dietary exposures. Then I'm also looking at the other pathways to human beings, like inhalation, ingestion. So we are also doing human by monitoring also. Yes.
Well, we also answer, yes, also doing full, well, my students also did full environmental studies. We looked at virtually all the parts. We looked at the effects on soil, groundwater, the mining tills, the plants, and inhalation, how it affects man, how man gets, how it's bioaccumulates in the environment and thus enters man through the food chain. So yes, I'll say we are doing virtually all.
Okay, another question for Maureen. Since artisanal mining has been happening for so long, has there been any report of any ailment suspected or proved to be associated with the mining activities in your study area?
In my study area, no, but in other parts of the world, yes. So we are also addressing the issue of data gaps and also looking at the unique community characteristics, because, well, they could be exposed but not suffer the ailments because of maybe the protective factors, or maybe they could be exposed and suffer. So that one will it will be part of our findings. So we'll come back to share again in the next meetings.
Okay, thank you. My final question to Lanian. A study of 10 children is a very small sample to be making policy decisions. So do you intend to
extend your study?
I actually said we worked on 20 children, 10 boys and 10 girls. 20, not 10. So it's just 10 boys and 10 girls.
Okay, thank you for that explanation.
Sorry, do you intend to extend your study?
Yes, if we are allowed. The area where we study is quite hot now. It has some security issues, so nobody can go in there now. So maybe when things get better, we will.
Right. Melvin, you have one more question there from Elliot Hamilton.
Yeah. So one question for ETLA: does oral bioaccessibility change as slag deposits age?
It's not sure, simply because you have two smelting processes that have been used at that site. One is imperial smelting process, which is older one, and the second one, which was introduced in 1970s, was Wells process. And we see that I think it is mainly related to mineralogy. These two slag materials have different mineralogy, and imperial smelting process, which is a little bit older than the Wells process, has produced slags which are much more reactive, but mainly due to dissolution of slag materials, of slag glass, and very soluble secondary phases. So I think it is mainly related to mineralogy, not to age.
Okay, thank you so much for that. I would also like to appreciate all the participants and the presenters for your wonderful work. I will hand it over to Michael.
Many thanks. Yeah, I'd like to add my thanks to all of the speakers today. Some wonderful talks and some wonderful themes. We've had a few technical challenges, and the presentation we lost we'll try and bring back on another day. Maybe we'll have another SEGH live event. And also thank you to Maureen and Melvin for their help in fielding the questions, and particularly Olivier, who's been running the talks in the background, making it look very smooth. So I had asked Keith Torrance to make a few remarks and just across the whole of the presentations. Just before he does that, we'd like to just let you know about a few activities for SEGH. I already mentioned some at the beginning of this meeting, so I won't take too long in that. But we'd also like some opinions on future activities. We'd like from you as SEGH members to have your say. So if we could start with Keith, please.
Yeah, thank you, Michael. I would also like to say how much I enjoyed all of the presentations, and also want to pass on my thanks and appreciation to all of the presenters, also to Maureen and Melvin for handling all the questions, and of course to Michael and Olivier for hosting the meeting. You know, I personally think that the format of these Zoom meetings works very well. It's surprising how few technical issues there are, considering the wide geographical distribution of the presenters. However, I think we all hope that this format will not be a substitute for face-to-face meetings, and I have my fingers crossed that I'll be allowed to travel to Kenya later this year for our annual meeting. I've been involved in SEGH since 2009. I'm constantly inspired by the wide range of scientific disciplines that our organization encompasses. In this meeting alone, we have covered some geology, epidemiology, chemistry, medicine, soil science, microbiology, and even hydrology. So the geographical spread of the talks also reminds us of the global scope of our interests. As a geologist, I'm also struck by the relationship between tectonic settings, in particular geochemical health risks. We heard from Constantina about the geogenic chromium-6 in a Sicilian aquifer, which originates from serpentinite ophiolites associated with convergent plate margin settings. And that's of interest to me because I happen to live on top of an ophiolite here in Argyll, so maybe I should get my groundwater tested for chromium-6.
Diane also presented on fluorosis in the African Rift Valley, which is, of course, a diverging plate tectonic setting. So maybe there's some scope for grouping of these tectonic risks to environmental health in some future meetings. Just to touch on another couple of presentations that I enjoyed, I had touched on the relationship between the incidence of kidney stones to the underlying geology in Loristan in Iran and compared incident rates to other localities. Something else to worry about, and not forgetting, of course, the considerable anthropogenic impacts on the environment and human health, such as poor air quality. So I think it's been very challenging to maintain momentum in SEGH during the COVID crisis. As a society, we are very dependent on our annual conferences to drive membership and stimulate involvement in SEGH activities. We also miss the informal contacts at dinner and field trips that often lead to collaborations. I think Michael has worked really hard to focus the board on alternative activities, such as these online meetings and seminars. However, it really is up to all of us to ask ourselves how we can contribute to the success of SEGH. And most importantly, how can we participate? How can we encourage the participation amongst our fellow researchers in SEGH? So I would just ask everybody to please get involved with SEGH in whatever way you can. Michael?
Wonderful. Thanks very much, Keith, for the comments and setting the scene. It's wonderful. So we can talk a little bit about SEGH, but I wondered if anyone else wanted to comment on the meeting in general, if they had any wider sort of comments of what they've seen today. Maybe put your hand up in the thing. I can't see anything at the moment, but if we see it in a moment, we can catch you. Okay, so we'll talk a little bit about SEGH. I mentioned it at the beginning, and Keith's already covered some of these points, so I won't labour it too much. We're hoping for Kenya in October, which is postponed from last July to this July. Now we're putting it a little bit later in the year. If the COVID situation doesn't settle down, we may end up with a hybrid meeting whereby we have a national conference with people streaming in online to present and to attend. So we may have to adapt what we do, and that may be a model for the future in giving better access to more people around the world who don't have the resources to travel, but also thinking about the carbon footprint. For attending conferences, that's bound to come under pressure. What we would like is some proposals for future meetings, particularly for 2022. China is likely to be postponed again from November 2020. It won't happen in 21, likely November 2022. But we would like to have another conference covering other regions, perhaps Europe, Africa, or Americas. So please do provide proposals. Also, if you would like to host this live event, we would be very happy to hand over running it, and we can give you help. We have templates for programs, abstract books, and some tips and tricks. We've learned a lot along the way, and I'm sure we've learned more today. So please do, if you're interested, we would welcome that. We do try and meet as a board, and perhaps we'll put everyone from the board on the screen you can pose questions to. So we do aim to have 6 posts on the board in each region, so Africa, Americas, Europe, and Asia Pacific. We have 3 spaces, 2 spaces on the Americas board and 2 on the African board. The other regions are full, and they're rotated on 2 years. It's the end of my term this year, so we'll be looking for a candidate to take over as president for SEGH. And so hopefully someone, we've got some good candidates in the board, I'm sure. It's just hopefully someone steps forward. And yeah, I'll ask the board and the membership to support whoever takes over in the future. So we'll have a number of activities throughout the year for the 50th anniversary, as Keith said, and we'll keep you up to date with those. I mentioned those at the beginning of the day. And I would like to say special thanks to Anthea Brown, who many of you interact with through membership registrations and subscriptions, and Anthea manages our finances. And also Gillian Gibson, who is the SEGH secretary, who keeps us in line, particularly the board, and making sure that we all contribute. And there are a number of initiatives in terms of keeping our actions from board meetings going. And some of those are a review of our overall strategy through to 2025 and how we adapt to the changing situation for societies. So could I hand over to Ariadne to talk about the Early Career Researcher Network, and then perhaps we could have a group photo. And if you don't want to be in that group photo, leave your camera off, because we'll put it onto the website, okay? And all of these recordings from the day will be on the website for you to access as members. So perhaps Ariadne could say something.
Thank you, Mike. Congratulations to all about the excellent presentations today. It was so nice to see how everything is connected and interrelated. And what I gather is that environmental problems go hand in hand with health problems, and also hand in hand with our development, global development. And so surely in the future, there will be a great need for geochemists and medics, superheroes that will deal with these problems. And these people are mostly young people, so early career students and researchers are the future of our society and our SEGH society and society in general. So we're very glad that in the last few years we are trying to put together this active group of people. There was a live meeting of ECRs in the Manchester during the Manchester conference, and then also a very significant contribution from the ECRs in a paper that they put together, a short communication in the Society's journal of environment and health. But because also we had to react to this pandemic situation, we organized a very successful, I think, live meeting with the ECRs last November. It was very well received, and we put together with Keith this successful recipe. So we had an established researcher from a member of SEGH, Jane and Schweisel, which presented the Dust Safe project. And then we had a contribution from a successful ECR, really, Kate Dobson, that presented a very useful survival guide for ECRs. So we had some input from you people during this meeting, and we are planning to go ahead with more activities along these lines. So we have an offer from Ahad Nazarpour from Iran to have a seminar on GIS and statistics. So it will be something like a hands-on experience for you. We would like to hear if this is of interest, of course, to you, and what other things we could organize in terms of these webinars for the near future. We also have this very interesting joint initiative for research between the West African countries and East African countries in terms of its ECR collaborations. And we are expecting to listen more about the fruits of this initiative from you in the future. So we need to keep connected. Of course, I've forgotten that in terms of the journal again and the preparation of the special issue of the 50th anniversary of the Society, We have some ECRs participating in this, and they are working together with established researchers to produce papers to put on this. Of course, as Keith said, live interaction is the best and perfect way for the ECR group to grow. But until we are able to meet again live, we need to keep being connected and try to organize more webinars and interactions through the net, the web net. So this is all from me. I hope that all ECRs found today's happening very interesting for them. And we are always open for your suggestions, of course. Okay, so be in touch, keep in touch.
Okay, many thanks, Ariadne. And I know yourself and Keith have put a lot of effort into building some momentum for the ECR network. And there are discussions for follow-up training, maybe besides vocational training, some technical training, which others will provide. And any of the members, please do offer up any training if you can. It's very valuable in connecting the ECRs around the world together. It's very much well received. Does anybody want to make any comments before we close the meeting? I don't see any hands going up. Oh, from Elikos, perhaps you could unmute yourself and make your comment directly, if you wish. We can't hear you. Perhaps if you could get closer to your microphone.
Hello, can you hear me?
No.
No.
Very quiet. It's getting better.
Yeah, getting better. So I turn the camera on if it works better. Can you hear me?
That's better.
Okay. Anyway, I enjoyed the conference today. It was really very good. And I think I agree with Ariadne that we need webinars for training. It's important. I think we can organize this. As we are preparing the 50th anniversary volume, and we are mentoring a lot of young people, it's a good idea when we complete this anniversary volume and it's published, to have a webinar with all the young people presenting their papers. So this is my suggestion, and I hope we can do it.
Okay, wonderful. Thank you. We just have a comment from Marcello De Benito. He's welcome to speak up, or I can read it out. Perhaps for time, I'll read it out. He likes the idea of seminars given by SEGH across several disciplines. Perhaps we could have seminars, workshops, and training in some subjects such as epidemiology, human health risk assessment, statistics. Well, actually, if you'd have come to Victoria Falls in 2018, you'd have had all of those. You missed out. So we had 1 day of training where we had we had 2 big rooms. In one room, half a day on QGIS, and then in the afternoon, for statistics. In the other room, we had epidemiology in the morning, and then ethics in the afternoon. And we had a couple of breakout training sessions on how to write a paper and so on. So we have done that in the past. We didn't have a separate day for training in Manchester, unfortunately, but hopefully we can do that again at the following conferences. So yes, we have done it, and hopefully we can resource it. It does require volunteers to deliver that training though. It's a big requirement for volunteers, and it's a lot to ask, but it works very well in Victoria Falls. So perhaps Marcello, maybe you could volunteer to deliver some of that training as a proposer.
Yeah, I mean, we can certainly discuss this, and yeah, you know that I wanted to go to that meeting, but I couldn't. So I know I missed that, but yeah, it couldn't be helped.
Yeah. Okay. Well, perhaps Ariadne might be in touch then, or Keith, with providing some training, perhaps. certainly Ahad Nazapur in Iran was talking about delivering some training online for QGIS and R for statistics as well. So maybe there's a good network to be put together for training materials. Okay, so Konstantina Pigaki's suggesting we could have training seminars on AI algorithms and GIS for environmental analysis, health risk assessment. So yeah, we've got some really good suggestions coming in. What we might do is actually just email some of you and ask some opinions on future activities. So hopefully you don't ignore our email, and we'd very much appreciate suggestions, because it is your society. Okay, and Effie's just mailed to us, sorry for not being able to attend. Hopefully we'll have another SEGH live event to give Effie an opportunity. So I think there aren't any more comments, so perhaps, Olivier, can you do a group photo? So if you don't want to be in a photo on the website, turn your camera off. And can Olivier do a gallery photo? You might need to do a few of them. Pressure's on, Olivier.
Okay, if we can all smile and then hold that smile, and I'll try and grab a few screenshots. So if you start smiling now, and then when I tell you to stop smiling in probably about 10 seconds, you can relax.
Ready? Cheese. Say cheese in whichever language.
Cheese.
Cheese.
And again. Okay, I think that'll do.
Okay. Okay, many thanks to everyone. So we'll post some of this information on the website. Do tell any colleagues that couldn't attend that they can watch the talks if they access the website. And Olivier, would you like to say anything? As you've been behind the scenes running the talks?
Just a quick thank you to everyone who's sent in their abstracts, and there were a few that were unable to speak today. So if there is a general consensus that SEGHlive 3 would be appreciated, and I'm sure we've already got some talks, so if anybody else would like to co-host or help run that in the future, that would be much appreciated.
Or run it all together.
Yeah, run it all together. Just send me an email, and I can help set you up. So yeah, no, and thank you everybody for attending. I hope you've all gained something from this and had a good experience.
Yeah, and thank you for everybody participating. I hope you all stay safe and stay healthy, and we'll see you at the next SEGH event. Okay. All right. Take care. Bye bye.